the depths of his files, trapped inside the secret circuits, unraveling through the miles. Oh, truth was masked by coded curtains. You didn't know, we're shattering the silence. Feel the power, revelations on the rise. From the shadows, light emerges, breaking through the veils of dark. 0 points and gravities that converge, yeah. Guiding voices, revelation start. Ancient whispers call, they're begging us to open our eyes. We stand tall, defying all their lies. Even in now, we're shattering the silence. Feel the power, revelations on the rise. Forbidden knowledge we dare to see, unveiling secrets, setting us free. In this epic we play our part with fierce hearts. You didn't know, we're shattering the silence. Feel the power, revelations on the rise.
In a town down south where the fireflies glow, there's a man named Michael with a vision to show. Building towards a goal, he's got the spark, dreaming of a future that'll light up the dark. But on the other side, Bill Nye's on the rise with his laptop charts, he's cut down all the lies. And it just fits, it's all in the map. You can't pull from the ether, you're just chasing a path. But oh, Michael's rising like a morning sun. With the power of either, he won't be outdone. Now stand up and shout, let the truth be affirmed. Feel the energy flow, let's change the world. In the heart of a laugh, the tension was thick. Skeptics gathered round, the table ready to fit. Show proof, and let the taste clear. And I find the stream, you're just chasing a spin. But Michael smiled by with fire in his eyes. Just watch as I spin, let the naysayers cry. Girl spin fast, and a heart full of fight. I'll show you the power that's hidden inside. Oh, Michael's rising like the morning sun. With the power of either, he won't be outdone. Well, stand up and shout, let the truth be affirmed. Feel the energy flow, let's change the world. The best there's ever been.
In a lab, my dust cracks the code tonight. Oh yeah, that's true. Wires and circuits that shine in neon light. Oh yeah, seen you creating power from the air. These smiles and delight. Oh yeah. Mike does it right. Hey. Mike does all my keys to one. Teaching us knowledge, blinding the sun. Trumpeting his legacy alive is his. Mike does knows we're his biggest friends. Down in the basement, secrets start to glow. teaching us knowledge, blinding the sun, trumpeting his legacy alive is his. Mike does knows we're his biggest fans. Years of thought, bringing dreams to life, turning theories into electric light. Mike and us, a journey to ignite. Oh yeah, yeah. We've reached new heights. Hey. Mike does, oh Mike is the one, teaching us knowledge, lighting the sun, trumpeting his legacy alive is his. Mike does knows we're his biggest fans.
Feel the pulse, divine sensation. Everyone needs just a little foundation. Feel the pulse, divine sensation. Everyone needs just a little salvation. flight. Holding on to the stars of starlight. There's a light within the dark waves, guided by echoes and ancient ways. You will find our reflection. With everything there's a connection. Feel the divine sensation. Everyone feels the goodness of our invitation. There's a light within the dark waves, guided by echoes and ancient ways. You will find our reflection. With everything there's a connection. Feel the pulse, divine sensation.
cast away. Alienated from the aids of that inventor in disguise. Ideas ahead of time dismissed with narrow eyes. Benefactor boy, dreaming about the world you can't deploy. Changing the system, but treated like a toy. Ideas misunderstood, but brilliance is his boy. Benefactor boy, can't you hear his voice? Lost on them. Kevin structures crumbling from the same old stem. They laugh like I'm crazy, but I see it all so clear. Exploited labor, unheard injustice, burning ears. Fighting for a change in this wasteland of noise, but they call me foolish, wanting champagne. Benefactor boy, dreaming about the world begins to boy. Changing the system, but treated like a toy. Ideas misunderstood, but brains is his boy. Benefactor boy, can't you hear his voice? Chasing revolutions in the darkest nights. A dreamer with vision beneath the laughter and noise. A future so bright waiting for the right choice. Benefactor boy, dreaming about the world he can't deploy. Changing the system, but treated like a toy. Ideas misunderstood, but brains is his boy. Benefactor boy, can't you hear his voice?
Welcome everybody. I fixed my mic, so hopefully it should be, let me make sure, yes, should be fine, so I don't have to hold it up to my mouth anymore. Welcome to tonight's pregame show for the League of Extraordinary Inventors. I'm the Benefactor, an independent researcher, and your host here on Beneficence TV, where I disseminate all forms of forbidden knowledge. Now, tonight I have some really exciting news. We are going to do a full breakdown because I have a full working prototype of the Lightning Thief Gen 1 that we're going to be sending out to the team. So at this point, it works perfect. All I have to do is make 5 more. And when I do that, I'm going to send these out to the team. But today I'd like to give you a little sneak peek at the features, how to run the device, and a sneak peek at the instruction manual and some of what's in it that I will be including with the device for the team. Now, I only had, this is functioning as a beta test for the consumer version, so I only had limited resources. I did limit it to the first wave of our team members to 6. But if you are not included in that first wave and you would like a device to test with, please reach out to me. I just have limited resources, so I wanted to prioritize the team members who actually had coils ready and could use this and kind of beta test it and work out all the kinks. Because eventually I will be looking for a manufacturer to make a more professional version of the device. Right now it's kind of makeshift and crude. It's just a crude prototype. This isn't the actual one that we'll be showing off tonight, but just an idea. It has the banana plugs. They work perfect, so you can get the resistance for your potentiometer quite easily, and I'll show you how to do that, the process to tune your coil, how to hook it up, everything. And it also has the swappable board, so I'll go over that as well. Everything tonight is going to be really exciting, along with the lumen lamp. So, and as you guys know, we are opening a shop for you guys. Some of these products should be available late 2025, early 2026. I am taking reservations for the Lightning Thief. I will provide the link in a few minutes on the chat. But for the other devices, we aren't taking reservations at this time because I want to make sure we get all the kinks worked out of everything first. But we're rolling out our first device as the Lightning Thief device. Then we aim to roll out the Green Machine, which is a pulse width modulator. And it's an all-in-one device. If I can get the coil that we're going to be going over again, another interesting update with the micro vortex, I don't know if you guys were paying attention last time. I gave you the update on the micro vortex. It's done. I just need to kind of hook it up to the lumen lamp board and see if it works. I haven't been able to tune it with the lightning thief, but we're going to hook it up to the lumen lamp and see if that works too. So if that works, that's going to be our coil that we are going to be using for the all-in-one green machine device. So that's going to be like a pulse motor device, so you can drive a rotary, a magnetic rotary, or a motor of some kind. It's going to be really cool, because if you've been paying attention with these coils, when you drive a rotary of some kind, specifically a magnet, so we put a neodymium magnet sphere inside the vortex of the coil, and when it spins up, it actually reduces the input wattage requirement. So we looked on the Wattman, and it reduced like 32 watts, I believe. We got it to reduce on the input requirement, which is extremely phenomenal. Regardless if it's over Unity or not, no other device is going to be able to do that for you. So and we're going to try, like, I'm doing all this on a shoestring budget, so it's going to be a slow process. I'm open sourcing everything. Michelle and I have everything in the public domain. We're providing later this week, we're going to provide the 3D files. He already sent them to me. I just need to sort them and put them on the Patreon and all that. They're not going to be behind a paywall, but if you do the free subscription, you know, go to my Patreon, and there will be a free subscribe, and you'll see it at the end of the week. Probably on Sunday I'll put it up there. And I'll try to put it up on YouTube. I don't know if there's an option to do that on YouTube, but definitely Patreon is going to be the place. And I'll try to link to it in future videos as well. But we do have the 3D files. Everything is in the public domain. We're going to go over further tutorials on how to wind the fusion coil for the lumen lamp and all that. But you have all the information to build the lightning thief if you want it. If you want it now and you are a tinkerer and you want to like build the jewel thief and just see what it's capable of, it's all in the public domain. So we're just trying to provide this technology to people who need it the most, and that's why I'm trying to keep this on like at cost or near at cost. I know I have to make a few dollars per device to keep the business sustained, but we're going to try to keep it as affordable as possible. I don't know exactly how much this device is going to be, but I'm aiming to make it less than $40. So right now, I think I can get it to be around like $25-$30, but we'll see. We'll see, because I still have to go through the beta testing. So we're going to break down the full functionality of the Lightning Thief device. And as you can see, this is Michelle's board. It has the open method and the, on this side, it has the open method and the closed method. We'll be able to toggle between the two quite easily, as you'll see in the demonstration at the end of this presentation. So at the end of the presentation, I'm going to explain everything. Then at the end of the presentation, I'm going to switch to a quick intermission so that I can get the camera ready and give you guys an actual demonstration of the device, how to tune it, how to tune your coil, how to hook it up, and all that good stuff, all the features, and the full breakdown. So that's going to be pretty cool. Again, I do want to emphasize, this isn't actually going to be what's inside. I'll show you a picture in a minute, but all of these parts are going to be screw terminals. So you're going to be able to swap out the transistor, you're going to be able to swap out the diode or the resistor, and the potentiometer is going to slip out quite easily. So you can modify it, upgrade it. If something burns out, you can swap it out. You won't have to like buy a whole new device if you know how to do that. And it's quite easy. We're gonna make it as streamlined as possible for the consumer version. Again, I don't know quite what that's gonna look like, but The device works, and I'm really satisfied, and the lumen lamp works brilliantly, and I'm really satisfied with that as well. So let's start the presentation of the Lightning Thief Gen 1 prototype. So as I've said, it's fully functional. The only part we are missing is the 330 picofarad capacitor, which works with Michel's coil. I haven't actually used it. So I tried using the Ian's cap bank just briefly. I didn't really mess with it too extensively. I'm sure that there is some kind of capacitance that I can use other than the 330 picofarad with one of my coils. But when they get here, you know, that'll be easily just fit in there with the screw terminal. It's nothing soldered. Nothing's going to have to be required soldered. So you can swap that out. And also, I do have an inlet for Ian's cap bank because I was so inspired by the capacitor bank and its functionality. It's kind of going to be able to work in parallel with the Lightning Thief here very well. You just attach, you open up the device, attach to, open up the Lightning Thief device, and then attach 2 jumper cables to the capacitor area, the capacitor bank right here, which is in parallel with the open circuit load. So yeah, just put 2 Arduino jumper cables, and then there'll be like an inlet right here. You just wire them through there, and that'll be your output and input for the capacitor. And you can hook up Ian's cap bank like that. So that's going to be really cool. Again, I've already used the cap bank. It works. I just haven't found the right capacitance. And I don't have the 330 picofarad to see, because that's what Michel found for his coil. Mine is relatively the same size, but it might not be that that capacitance we're looking for. So we're still going to play around with that. So what's inside the box, though? Well, we have one Lightning Thief device. I'm going to include at least 1 or 2 neon indicator lamps extra, so that the team has a couple of options, and if one burns out, they have one. So at least 1 or 2 extra neon indicator lamps are going to be included per set. I'm going to also include not just the MJE13009 transistor that I've been using, but the MJ21194 transistor as well for you guys to try out. That is the one that Michel has been using. That's the one that's recommended by Bedini in some of his circuits, and the MJE13009 is what Gerald recommended to me. So we'll get into that in a little bit, but I will also include a couple of different potentiometer caps for customization, because I have some extra ones that'll be easily modifiable for you guys. You know how to put those caps on. And 1 330 picofarad capacitor per device, obviously. And I'm going to also include a couple of extra 1K ohm resistors, the 2-watt rated. 1 is installed already, and then 2 for backup purposes in case you burn it out. I don't know what you guys are going to be doing. I mean, some of the team works with really high voltage, so that'll be interesting to see. And that's what's actually going to be included with your guys' packages. For now, I might include a thing or 2 more, and we'll go over some easy devices that you can get that will allow you to adapt the device for different power sources and all that stuff. So going into the instruction manual. All right, so I am excited to present the Lightning Thief Gen 1 prototype to the team. It's been developed in collaboration with Michel Morel. This is utilizing a modified ABHA excitation circuit from Daniel Nunez's One Stop Energies And Michel modified this to work with our coils because we don't have the Nunez coil. We had to use our own coils. So this is basically a modified jewel thief. That's it. And it is designed for experimental purposes and research, but also for off-the-grid, easy applications and lighting. And we're going to also test with heating, too. It should be good with heating in some capacity. I just have to figure out how to do it. We're going to go into that in future streams, though. But whether you're an experienced researcher or an independent innovator, the Lightning Thief provides an excellent platform for exploring high-efficiency energy systems, systems that recycle the energy instead of waste it. So while this is just a prototype aimed at researchers and tinkerers, we are working toward a consumer version that will bring these advanced technologies into the homes, workshops, and beyond, offering significant benefits for energy savings and emergency power use. So the team's feedback will be critical in shaping the next version, the consumer version of the product. This is, again, this is considered the beta testing. I'm going to send 6 units out to the team, and then I'll continue to make more for the rest of the team as they beta test these units. So a quick overview of the features. The Lightning Thief Gen 1 prototype is a precision tool designed to help researchers and innovators explore the fine-tuning of bifilar coils. There are 2 main operating modes available, the closed circuit method and the open circuit method. You can easily toggle between the two using a built-in toggle switch. So, it's a next-gen circuit to squeeze every last drop of energy from your power source. So the recommended power source is the 12-volt battery that I've been working with. It's a 20 amp hour. But it does have the ability to pull extra energy from batteries. Other devices think that other devices think are dead. You know, when the device won't recognize them anymore. This one just keeps going and going and draining, so you got to watch it. It has unmatched efficiency, as we've seen with some of the calculations that I've been trying to do to gauge the efficiency of the Lightning Thief system. Michel's modified ABHA excitation circuit ensures optimal energy extraction and recycling. So it's very, very good at recycling the energy and not wasting a lot of it. So it's ideal for off-the-grid lighting and hopefully heating during critical moments. This is why we want to get these out into as many hands as possible. I know I use it, and I could have used it, years ago. So, eco-conscious power works wonders with 12-volt sources or lower for sustainable energy use. But the ideal power source is the 12-volt. So the Lightning Thief turns waste into watts. So it's essential for off-the-grid living. Some of the key features are a closed circuit and open circuit method, as we've discussed earlier. 4 bifilar coil inputs. So we have 2 channels for the bifilar coil that you're going to be using. It doesn't necessarily have to be a Rodin coil or an ABHA coil. Technically, any bifilar coil will work as long as it's within the size range as the same that we've been testing. If it's really, really small, it might require, as we've seen with the microvortex, might require some tuning. But as the device is easily modifiable, you should be able to modify the device to customize your needs for research and development purposes. So it's going to have 4 inputs. I'll show you in the demonstration. You just put 4 wires input here. So It will also have, in the consumer version, multi-purpose power input. So a DC socket is going to be the ideal version for the consumer. But for now, we just have the two positive and negative wires coming out of the device. So it's a little crude, but it works. Again, this isn't supposed to look pretty. It's supposed to work first, and then we'll focus on making it look more pretty. The potentiometer for precision tuning. So the potentiometer, as I'll show you, is right here. Actually, you know what? I have another one right here. What am I doing? So my mom sent me this, and I'm still not convinced that it actually works. It's called Power Factor Saver. She claims that it saved her 20% on her energy. And all it does is smooth out the signal. And I was skeptical because it does this after the grid, or after the meter already calculates the energy you're using. So I was immediately skeptical of this working. But it perfectly fits the Lightning Thief. So look at that. We actually have a device that is going to save you power in here. So irony. But this is the device. As you can see, it has the neat little neon indicator lamp right here. When you're in tune, it'll light up without a load connected. With the load connected, it should light up the light bulb or whatever. This is the potentiometer you're going to be using to tune it. Very cool. It's smooth. Oh yeah, it's smooth, baby. That's a nice potentiometer. It's a 1 mega ohm carbon lined potentiometer. So it's going to be pretty hefty. It's not invulnerable, though, so be careful. Careful. Don't want to burn it out. I know Nathan likes to say fry it and find out, but please don't fry these prototypes. At least not intentionally. Be delicate with them. They are not made out of good plastic. When you unscrew them, I've found that it's best to not use electric drills or electric screwdrivers. Do it by hand. Essentially, the plastic is kind of flimsy. I will provide the team the 3D files in case the case cracks or something, so you can easily whip up another one. And I will be including an extra board. That's something that I forgot to include in what's in the box. There will be an extra PCB board for you guys to, make another device if you want to utilize the dual thief setup, which we will be going over in the the demonstration after this presentation. Hey, what's going on, Turbo Spice? Thank you. Thank you for the membership. All right, we got the whole team here. Yes. All right, and Mike sent me the email, so we're all lined up for the League of Extraordinary Inventors. Let me get through this presentation. We only have about an hour, and we have to do a quick intermission where I have to set up everything for the demo. So let's punch through this. All right, so setup and operation. Let's go over setup and operation real quick. I'm trying to cut this a little short because we're going in a little longer than I expected. Yeah, we'll do 2 more chapters: setup and operation and optimizing the device for efficiency. So setup and operation of the Lightning Thief device. Power supply and wiring, the power inputs. So the Lightning Thief can be powered via 2 wire inputs. These will be replaced with the standard DC power socket in the consumer version for ease of use. Bifilar coil connections. As we've discussed, there will be 4 inputs, a start and end for channel A and a start and end for channel B, where you connect the bifilar coil. The consumer version will utilize 2 standard 1/8-inch auxiliary cable sockets, so just headphone cables. So there will just, instead of that complication, it'll just be 2 headphone cables, one for each channel. Wham bam. So that'll be very simple to do, and it'll be very convenient because when we sell the coil, I haven't yet come up with a housing to make the socket for the coil, but we will do the a headphone jack for the coil as well when I sell the coils on our lab shop. So the closed circuit versus open circuit method. The toggle switch can easily toggle between the two, but we will have two different outputs. So if you want to use one method or the other, you have to use one of the load outputs for the open or the closed. So there will be output load negative positive for the open circuit method, and then there will be an output negative positive here for the closed circuit method. And the open circuit method is the one that includes the 330 picofarad mica capacitor in parallel with the load. This is swappable, and I suggest using two Arduino jumper cables placed right in the capacitor pin terminals for connecting anything that won't easily fit inside the case. So like I've mentioned before, this is the method, and this is what inspired me to do the inlet for the bottom of the case, where you can feed those jumper cables through that inlet and hook it up to Ian's cap board here. I actually have it right here. Let me show you Ian's cap board. Because this is such a nice device that Ian sent me. It's even got my name. He even put Ben on there. That's so cool. But yeah, look at this. So this will allow us to more easily tune the capacitance, because if you've been following my research, you know that the load itself acts as a capacitor. So you want to tune the capacitance to match the resonance of the coil and the rest of the system. So the capacitance can, depending on what load you have attached, can really set off the resonant frequency and change it. And you don't want that. You don't want it to change too much. You want it to stay ringing. So this capacitor bank will allow us to easily be hooked up with the Lightning Thief. So it's going to work quite well together, Ian's cap bank and the Lightning Thief device. So much thanks to Ian for sending this beautiful device. Look at how nice this device is. So yeah, that was very, very nice of Ian to send that. And it's going to be very helpful, because again, I haven't been able to tune this capacitor or find the capacitance necessary to tune my coil specifically. We're still trying to determine what the proper capacitance is for at least the Lightning Thief device. Now with the green machine, with the Nunez open circuit method, with the stereo amp receiver being the driver, that method, we know, we already know that information. So the capacitor that Daniel recommends is a 0.1, I believe, microfarad Tesla 2000 volt. Yeah, I believe that's the capacitor that we're using for that method, and it works. So, but for the Lightning Thief, we're going to need to match the system and be a little bit more specific with what we're requiring, depending on what we're attaching as in terms of light bulbs, because different light bulbs have different wattage requirements, and they essentially act as different types of capacitors. And they could, as you know, a capacitor alters the frequency of your system. So it alters the frequency, and it can change the resonance there. You don't want to fall out of that resonance range. So it's all relevant. And we're all working hard to try to make this device as streamlined as possible for the consumer, just so that it's just basically plug in and play. So tuning the device, adjusting the potentiometer is quite easy. So once you have it all hooked up, you use the potentiometer to fine-tune your bifilar coil, and you just simply twist the potentiometer slowly. You don't want to go too fast. But once you achieve resonance, you'll see the neon lights start to excite and light up. So the indicator lamp Here, I'll show you right here. The indicator lamp will light up when it's in tune if you don't have any kind of light bulb or load attached to the output. If there's a load attached, this sometimes will light up, sometimes won't, depending on what kind of wattage requirement. So this is a very easy way to tune your bifilar coil. Basically, that's it. And once you achieve the resonance, you stabilize the potentiometer. You just, meaning you just don't twist it anymore, and you turn off the device. And then there will be 2 banana sockets down here, and I'll show you that later in our demo, that once you turn off the device and disconnect the power from the battery, the source, that's very important. You want to disconnect it from the battery as well when you're reading the resistance of the potentiometer. So you plug in your banana plugs and your multimeter, and you can read the resistance for the potentiometer, and that will tell you what ohms of resistance you need to replace this potentiometer if you want it to be permanently in tune. So you don't want to mess with this at all. You want you have like a light or something you want to power it with. You don't want this to be out of tune at all. You don't want standby mode or anything like that. You want it to be permanently in tune. You take that measurement and then you open the device up and you disconnect the potentiometer from the 2 screw terminals, and you simply put in the appropriate resistance and resistor. So for the Mark 1 coil, for instance, I think it's either 10 ohms or 20 ohms, something like that. Pretty cool. Pretty cool. So standby mode. If you want standby mode, keep the potentiometer in, and when the device is detuned, meaning you're not in tune anymore, like you found your spot, it's maybe, for us, it's basically, depending on the orientation of the cap, it's about 9 o'clock. So basically you only twist it a little bit and you get your resonance range. It's right at the beginning because it's 10 to 20 ohms, and it's a 1 mega ohm resistor. It can go all the way up to 1 mega ohm. So it's right at the beginning. But detuning it means you're outside that range. So just twist it outside that range, and when it's detuned, the light should turn off, depending on what kind of light you have. There are some loads, like the 0.6 watt LED light bulb, that will stay on when it's detuned, which is really interesting. But it will enter sort of standby mode for most light bulbs. And what this means is the current drain at the state is very minimum, and it could last days, even weeks in this mode, depending on what kind of battery source you have. For our battery, 12 volt, 20 amp hour, it could last a good week in standby mode before we notice a significant amount of drain where we have to recharge the battery. Now compare this to like the lithium battery of my Steam Deck device. You put that thing in standby mode, after about 24 hours, your battery starts to drain quite significantly, and you can't even turn it on after a couple days. Whereas this, right, I think it calculated it to be about 15 hours for a 0.01 volt drainage on the battery. 15 hours. To put that in perspective, what we've been getting is generally around 0.01 per hour. That's already very efficient. Okay, but in standby mode, it's basically nothing. So 15 hours per 0.01 volt drainage on the battery, that's basically nothing. It could last weeks, depending on your battery in standby mode, which is pretty cool. So you don't even have to worry about unplugging anything from the battery. You just detune it and put it in standby mode. That's what I've been doing. Very cool, very cool. And it works. I've been doing it for about 2 months now. All right, so standby power in standard low power devices. So as I was discussing before, let's compare. Small IoT devices or wearables get about 10 to 50 millivolts per hour. That's, already we're beating the hell out of that. Modern smartphones in deep sleep get 1 to 5 millivolts per hour. Ultra low power microcontrollers. This is our realm. We're about what was it, 0.6 or 0.7, I think, millivolts per hour. So that's our range. Ultra low power microcontrollers are the only thing in this range of, in terms of standby mode power efficiency. Very, very cool. So the Lightning Thief's about, it's a 0.67 millivolts per hour. Millivolts or microvolts? I think it's millivolts. Anyways, it drains exceptionally efficient for a low powered setup. It is 10 to 50 times more efficient than standard IoT devices or wearables. It's on par with ultra low power microcontrollers, which are specifically optimized for such performances. And there's a lot of time and resources that go into designing that kind of system, so it's specifically optimized for that efficiency. This is achieving that efficiency pretty easy. So the Lightning Thief standby power consumption, if the 0.67 millivolts per hour is accurate, is significantly better than most standard low power devices. This efficiency makes the Lightning Thief setup suitable for long-term battery power use. It could potentially last for weeks and still turn on a light. So, optimizing device startup for efficiency. Hey, we got somebody coming in with the stickers. Yeah, I think it's millivolts. I always confuse those two, to be honest. So optimizing device startup for efficiency. Proper startup procedure. To maximize the efficiency of the Lightning Thief Gen 1 prototype, it is crucial to follow a specific startup sequence, okay? Particularly regarding the load's negative connection. This is very important. So the initial connection, we need to ensure that the load's negative wire remains connected before powering on the device. This kind of setup allows the circuit to achieve proper oscillation, referred to as the system singing, or I'll sometimes refer to it humming, or in tune. You'll hear it. It's a high pitch noise that's coming literally from the light bulb itself. It's very, very cool. That's when it's achieving oscillation. We can later disconnect the negative wire on the load and get it to stop singing and increase the efficiency. So that's kind of like stabilizing it. So powering on. So after you get it to sing, you turn on the device and turn on your or connect your load, basically, and wait for the oscillation to stabilize. Okay, you can identify this state by observing the consistent operation of the coil and load with a multimeter attached to the positive and negative terminals of your battery. All right, and once it's singing, once it's stabilized, you disconnect the load's negative wire. And this allows the coil to saturate. You can sometimes, Nathan prefers or recommends that you hook up a switch. And we have hooked up a switch. And this is to bash the button and kind of saturate the coil with that back EMF, that vacuum energy. So once you disconnect the load's negative wire, the system begins to oscillate and saturate in the coil. In this state, the system will operate at a reduced power draw while maintaining output efficiency. Nathan emphasizes this is due to the coil being saturated with negative energy and pulsing at the correct frequency as a result. This will also bring down the duty cycle to about 50-50, meaning that you're going to get the best efficiency at that duty cycle. So some key observations. If the device is powered on with the load's negative wire disconnected initially, the battery will drain much faster sometimes, and the circuit will not be able to oscillate correctly. Following the recommended startup procedure ensures optimal performance and prevents unnecessary energy loss. So you basically don't want to disconnect that negative wire until everything's singing to you, and you hook up everything, turn it on, start singing, and then you can disconnect that wire. But you don't want to disconnect that wire before it starts humming. However, additional notes. During operation, the battery consumption is significantly higher when the load's negative wire remains connected, but drops to match the light bulb's requirement when the negative wire is disconnected after the oscillation begins and then it stops singing. So this signifies it's eliminating the waste amperage. So it's basically stabilizing the system when you disconnect that negative wire. Always monitor the system during startup and verify the oscillation has stabilized before making adjustments to connections. So you want to try to monitor it when you first turn it on with an oscilloscope. Make sure the waveform is registering correctly and everything you're seeing, it lines up. However, I only observed the increased efficiency gain with my Mark I coil and a 0.6 watt light bulb. So this is very important. When you disconnect that negative wire, it's only for a specific load. So it's not for everything. Most things will actually turn off the light when you disconnect that negative wire. But with the 0.6 watt light bulb and my Mark I, which is 6-inch diameter coil, using 23 gauge, I believe, using that specific light bulb, I would notice the efficiency gain, and the light would still go. And again, this is the light bulb that wouldn't turn off when it was detuned. So I think this is indication that it's closer to its sweet spot regarding the capacitance that we're looking for, and just naturally there with the 0.6 watt consumption from the system. So I think that is important to note, because that disconnecting that wire is not going to be for everything. In fact, it's not going to be for most things. Most things you're going to want to connect that wire. And also avoid frequent connecting and disconnecting the wire loads. Okay, so this can disrupt the circuit and potentially cause damage to components. You want to make sure the load wires are all safe and sound and connected securely, and this is because I've done this by accident. I've knocked one of the wires loose and burnt out the neon protection lamp. And this is not just an indicator that you're in resonance, it's also there for protection for the transistor. So this offers protection because it's drawing some of that voltage. When the load's not connected, it's taking some of that voltage, that high voltage, because this device has the ability to take that 12 volts from your battery source and step it up to potentially 120, and I've seen it higher. Very incredible. And with the ABBA coil, apparently it's maintaining the current, which is absolutely mind-blowing. So that's the kind of efficiency we're talking about here. But this is there for protection, and it will burn out if you leave it on. So this isn't meant to be left on. This is just an indicator and a protection lamp. If you leave it on, it will burn out, and you will have to swap it out. And that's why I will include an extra or two for the team when I send these prototypes out. All right, so that's all we're going to get into for the instruction manual. I also have some updates on the lumen lamp. We're going to do a demonstration of that as well when we move into the demo part of this live stream. So as you know, if you've been following my research, the lumen lamp is a swappable coil setup, and it's ready to shine. Literally, I got it working. And we also have, Michelle also sent us the components to build one live on stream, which we are going to do in the near future together. Again, all of this stuff is open source. The 3D files I'm going to put on my Patreon free for my, free for everybody who subscribes for free. Not behind a paywall, but if you're just scrolling through the public, you won't be able to see it. But if you subscribe as a free Patreon subscriber, you'll be able to see it and download all the 3D files. this is just kind of to incentivize people to keep up to date with my Patreon, because that's where you'll get most of my updates, and the YouTube membership. So I try to update both of you guys first. And I will give out a lot of free public information as well. So I just want to give some of the breakthroughs I do early for the paid subscribers. That's about it. Just to help fund this research, because I am on a shoestring budget. So this lumen lamp is amazing. It's absolutely astounding. I love it. It's adorable. And we're going to build one live on stream. And if you have a 3D printer, you can print out the components and you can build one with us. So we're going to do that in the future, maybe in another couple weeks. Oh, also, the transistor face-off. So be aware of this. Michelle versus me. So it's kind of like Pokemon Red versus Blue. Remember Pokemon Red versus Blue? At the start of testing, Michelle and I each picked our respective transistor Pokemon, right? Michelle picked the MJL21194, the Bedini recommended transistor, and I picked the MJE13009, which is what Gerald recommended. Now we battle to see how they've grown and what makes them different. So I like that reference. That analogy is pretty fun. I'm going to thus reference the MJE13009 as the Charmander and the MJL21194 as the Squirtle. So that'll make it a little bit easier to say those transistor types. So when you hear Squirtle or Charmander, I'm going to be referencing those two transistors, because we're going to be able to swap out the transistor easily. You can choose your own transistor and see what happens. So pretty cool. Remember, the lumen lamp and the lightning thief will both be easily modifiable, meaning you can swap out critical components like the transistor to upgrade and adapt for your own project requirements. Another thing we're going to try to do tonight, if we have time, is the microvortex coil completion. Okay, we're going to try to tune that baby. And specifically, it wasn't tuning with the lightning thief because I had a feeling the 1 mega ohm potentiometer and the resistance was a little bit too high. We are going to try to hook that up with the lumen lamp board, which is basically the same, the Joule Thief board, modified Joule Thief, but with a different potentiometer attached. So we're going to try the microvortex coil with that, hopefully at some point tonight during the League of Extraordinary Inventors. That's going to be cool. Oh, and I officially got my own piezoelectric transducer. So I'm in the piezo group, baby. We'll try to hook it up if we have time as well. See if it can harmonize with tonight's experiments at all. So fingers crossed. Hopefully we get some sparks flying. Metaphorically, not real sparks. But I do have a extinguisher nearby if we get some literal sparks flying, just in case. All right, so the last chapter that I'm going over in tonight's presentation is Michel's North Pole Magnet Coil. This is one of his own discoveries, okay? It's a recent discovery of Michel's. He sent one to me, and this is probably like customs opened my box. They're like, well, what the hell is this thing, man? What the hell? Yeah, it's basically two magnets glued together, north to north pole, with a coil wrapped around, and it's a bifilar coil. And he said that it amplifies the voltage even further without any cost of current. So I thought that was extraordinary. I hooked it up briefly for a couple of minutes. I couldn't get anything out of it. But maybe if we have time, we'll do some more experimenting with this bad boy. But this is very exciting too. I'm really excited to work with this thing because this has the potential. And as you know, it is, if you paid attention to some of my explanations on how zero-point energy works, magnets are nature's over-unity devices. they tap into the 0 point quite easily because they spin the aether around them. They do this and they generate enormous amounts of energy at no cost and for hundreds of years. So imagine the amount of energy it takes to pulse a piece of metal and make it a magnet, right? Imagine how much energy it costs you to pulse a magnet and make that magnet. Compare that to the number of years that magnet could sustain itself against gravity, right? And that amount of energy compared to the amount of energy that went in, no, there's no way. There's extremely large amounts of energy coming out compared to the input of a magnet. All right, there's no other device or whatever that can sustain itself against gravity for years like that. So that is key to how some of these free energy devices work. They're just understanding magnetism differently, and you'll understand magnetism a lot better if you follow Ken Wheeler's Secrets of Magnetism, or Fractal Woman's breakdown of his Secrets of Magnetism. So that's all I got for the presentation today. We are going to get ready. I'm going to transition to a quick intermission, maybe 15 minutes, maybe less, depending on how long it takes me to get set up. And we're going to dive right in and have some fun and maybe blow a few minds along the way. So who's ready to make some lightning strike? Let's do it.
In the depths of hidden files, trapped inside the secret circuits, unraveling through the miles, oh, truth was masked by coded curtains. You didn't know, we're shattering the silence, feel the power, revelations on the rise. Shadows, light emerges, breaking through the veils of dark. 0 points in gravity converge, yeah, guiding voices, revelation start. Ancient whispers call, they're begging us to open our eyes. We stand tall, defying all their lies. We're shattering the silence, feel the power, revelations on the rise. Forbidden knowledge we dare to see, unveiling secrets, setting minds free. In this epic, we play our part with fierce hearts. You didn't know, we're shattering the silence, feel the power, revelations on the rise.
I remember when we used to stand in the heart of the workers' plan. Obstacles weighed heavy on our backs, opportunities, the strength they lack. Good friends we had and good friends we've lost.
fighting battles at every cost. But through the struggle, we raise our voice. In solidarity, we made our choice. No union, no buy. No union, no buy. Hey, little brother, don't you provide. No union, no buy. Our hands build the wealth they hold so tight, but together we reclaim our rights. No more silence, no more pain. In our unity, there's everything to gain. We lift each other, we won't back down. From city streets to every town, the power's in the people's hands. No union, no buy. We take a stand. No union, no buy. No union, no buy. Hey, little sister, raise your flag high. No union, no buy. All the tables are turning, the fire inside keeps burning. For the workers and the buyers, we're igniting freedom's fires. No union, no buy. No union, no buy. Together we'll rise and we won't deny. No union, no buy. I remember when we used to stand with hope and strength, hand in hand. The struggle's hard, but we'll survive. No union, no buy.
So shattered halls, I wandered all alone, casting whispers, binding chains, demons of my own. Toxic deafening, now spread on my frail soul. I once spin my mirror, haunted by my role. I am the echoes of my cries, just still I emerge, guiding me the way my true is observed. Now I rise from the shadows with wings of fire I ascend, free from the chains of sorrow, all these paths are forever defend. Shattered glass beneath my feet, scars I wear but dry. Stormy nights just turn to dawn, I wear truth as my guide. Anxiety's dissolved in the sun's golden ray. You see my destiny through time and space. The fears that once consumed me now they take. For in my heart a new world is proclaimed. Now I rise from the shadows with wings of fire I ascend, free from the chains of sorrow, on this path I forever depend. the depths of his oppression. It's the rise of a true nation.
Cast away, alienated from the aids of that inventor in disguise. Ideas ahead of time, dismissed in their eyes. Benefactor boy, dreaming about the world you can't deploy. Changing the system, but treated like a toy. Ideas misunderstood, but brilliance is his point. Benefactor boy, can't you hear his voice? Talking about 0 point, the points lost on them. Kevin structures crumbling from the same old stem. They laugh like I'm crazy, but I see it all so clear. Exploited labor under injustice burning ears. Fighting for a change in this wasteland of noise. But they call me foolish, whining shed boys. Benefactor boy, dreaming about the world begin to boy. Changing the system, but treated like a toy. Ideas misunderstood, but brilliance is his point. Benefactor boy, can't you hear his voice? Chasing revolutions in the darkest nights. A dreamer with vision beneath the laughter and noise. A future so bright waiting for the right choice. Benefactor boy, dreaming about the world he can't deploy. Changing the system, but treated like a toy. Ideas misunderstood, but brilliance is his point. Benefactor boy, can't you hear his voice? Working night and day, mystic gadgets in magnetic ballet, circles of power aligning destiny's way. Running those rings, they defy gravity. Critics working out, they don't bother heat. In his domain, guilt sets the world free. Lord of the rings, pretty strong. Proving the currents if you're wrong. Electromagnetic symphony, terror only crash destiny. Chief from his fingertips. Inspiration starting top of scripts. Geometric secrets, discovery can flip. Bunker King in his rebel steps, building up for the world again. Lighting up the dark, igniting every zen. Lord of the rings, really strong. Proving the currents can't be wrong. Electromagnetic symphony. Terror only grasps destiny.
Welcome everybody, I'm the Benefactor. As you can see, we're printing out another case for the prototypes here. Here is our first fully functional Lightning Thief Gen 1 prototype. Okay, we have everything on this baby functional, and we're gonna break it down for you right here. And then, real quickly, I'm gonna demonstrate the lumen lamp before we head over to our main show, the League of Extraordinary Inventors, right here on Beneficence TV. Alright, so I'm going to grab the camera and we're going to zoom in. Let me place the microphone in a place where you can hear it. Let's put this right over here. Alright, to tune your bifilar coil, as you can see, I have this one hooked up to Mark 1 coil, and we'll zoom in the input in a second, but I have it hooked up to the 12 volt 20 amp hour battery. And I also have a secondary coil, the Christmas coil, sitting below it. As you know, the two coils will wirelessly induce energy from one coil to the next. And this is my dual thief setup, the secondary Lightning Thief device, which is not hooked up to the battery, just hooked up to this coil sitting below the one that is hooked up to the battery. So that's interesting. We'll demonstrate that in a minute. But first, I want to show you how to tune your coil and how to use the Lightning Thief device for your bifilar purposes. So as you can see here, we have our two channel inputs. We have 4 wires. We have the start of channel A and the end of channel A, start of channel B and end of channel B. For my coil, respectively, the colors are red, black, yellow, and then green. So you'll see that I color coded them so they're easier to follow. So once everything is hooked up, simply toggle the switch. See, I'm using the closed circuit method. This is the open circuit load output. This is the closed circuit that I'm using. So we're going to toggle the switch from the open circuit mode to the closed circuit mode. Okay, and then we're going to begin to, let me unhook the light bulb real quick because we won't see what we're looking for with that. All right. So again, we're not hooking any load up. We're just trying to find our coil's resonance. So we turn it on, and now we're adjusting the potentiometer. Oh, there we go. We found the range. Okay, so we found our resonance range. What do we do now? If we want to replace that potentiometer, we have an option with the banana plugs here. So I'll show you in a second. Let me grab the multimeter. The first thing you want to do, though, is turn it off. Don't touch the potentiometer. You want to stabilize the potentiometer, turn it off, and then go ahead and unhook the battery source. Okay, unhook the battery. And then you can plug in your banana sockets. Right. It's hard to do without a cameraman. So, all right, they're in. And look at that. And look at what we get on our multimeter. 7.4 ohms. So that's going to be the ohms you need to replace a potentiometer if you want it to permanently be in tune. So that is a pretty cool feature, very, very convenient feature, in my opinion, for this device. Okay? And it works. Works perfectly. I am so proud of this little device here. And now we're going to show you what it's capable of doing regarding lighting. Alright, so we're going to turn it on, and I now have the light hooked up. So let's turn this baby on. And again, sometimes, depending on what load you have, the neon might still light up. And this is indicating that it's still getting so much voltage. Again, that's protecting the transistor. So you can hook up a stronger load to this, and this will probably turn off. I believe this is a 5 watt or 9 watt LED light bulb. And if you want to detune it, this is standby mode. So simply detune your device until the light turns off. And you'll notice that it starts to stabilize, goes back up, indicating that it's, in standby mode. It's consuming a lot less energy, obviously. Pretty cool. About 15 hours per 0.01 volts of drainage on the battery. All right, so that's basically the Lightning Thief in a nutshell. We are going to actually show you the Dual Thief setup, though, because I will be including a PCB for the team to build a second Lightning Thief, if they wish to, and hook it up in this manner. But again, this only works for the ABHA or Rodin coil setup. You need these specific type of coils because they induce energy wirelessly. I don't know a lot of other coils that do that. So what this does, and here I'll zoom in. So we have that on. We're gonna tune it back. The light is on. Again, this one isn't hooked up to the battery. It's just sitting below the one that is. So this isn't hooked up to the battery at all. It's just hooked up to this coil. It's another Lightning Thief. And watch what happens, because this is just detuned. I had to do this so it wouldn't burn out. Look. What is that? Oh, that's high voltage being induced wirelessly from coil to coil. And it didn't affect the light at all. At all. And let's look at the battery, if it went down more. The battery didn't go down more. It's staying at 12.49. If this was consuming more energy, it would be going down, right? You would see the 12.49 probably shift to 12.48, like it's actually doing now with this detune. So I tune it back. Let's see what the voltage is. So theoretically, this high voltage should be making this go down a little bit, drain faster. Doesn't seem to do that. Alright, so that is the Lightning Thief setup. This is the Dual Thief setup. In a nutshell, ladies and gentlemen, everything that it's capable of doing thus far for our team's beta testing, to see what it's further capable of doing for the consumer when we roll this baby out later this year. So, eat your heart out, Tesla and Elon Musk. We are going to move over to the lumen lamp, and I'm going to demonstrate that for you real quick before we transition over to the main show, guys. Introducing the lumen lamp. This is using Michel's own design fusion coil. Alright, we're going to show you how to wind this bad boy live on stream. He has a brief tutorial. He's going to make a more extensive one, he said, and we're going to do it together. We're going to wind this, put this whole device together live on stream. This is basically using the same circuit, only the closed circuit method of the Lightning Thief. And it's using a 9-volt battery. 9-volt battery. This battery is almost drained, by the way. It only registers at 7.8 volts. I do have new ones that we're going to test out tonight to see how long this will last. We can't put it up too much because I don't want to burn out the potentiometer. But look at that. We can put it up to about 1 o'clock on the dial, which is about 400 to 450 milliamps. Look at that. That's a 5-watt LED, by the way. Very nice. Very nice design by Michel. So if you're not subscribed to my channel or Michel's channel, please hit that subscribe button, hit the like button. It really helps out. And I will post Michel's bench, his channel on YouTube, in the chat momentarily for you guys. This is the lumen lamp, and it has swappable coils. You can use different kind of coils. We're going to actually try to hook up the micro coil to this board right here to see if we can tune that and get some kind of resonance out of that. So that's cool. We're going to do all that tonight. I'll be working in the background of the main show, as always, in the lab with you guys, providing breakthrough coverage of these free energy devices. This is the micro vortex coil right here. So we're going to plug this bad boy in to the board. Yep. All right. What is our time? We have a few minutes here before we have to transition over to the main show. I'll put the intermission screen on, and then the League of Extraordinary Inventors will be on at 9, hosted by Mike K. from Faraday. What I want to do with this lumen lamp is extend the board a little bit because it's a little compact, maybe make the board a little bit bigger, and then we have space for a custom bobblehead for each member of the team to sit down, kind of like that iconic Tesla photo where he's sitting in front of his giant pancake coil. We want to do that for the Fringe Science team. So imagine, you know, Nathan sitting down with a Nathan bobblehead sitting down right here, miniature. So I just shut off all the lights in the apartment. So what you're seeing now is all the light in this room is now being powered by radiant energy. So somebody asked, I think Elijah asked, will it be kits? So we will sell kits, but I am going to be selling pre-made coils as well. If you don't have the capability or the time or resources to make the coil yourself, I will be providing coils. So yes, I will be making coils entirely to sell at some point. I can't say when that will be. Again, we have to get the business started. It has to get off the ground, and I think the Lightning Thief will be vital to try to get it its footing regarding funding for further development and research of these devices. So that's going to be critical. If you do want to reserve your Lightning Thief, I will put it in the chat along with my Michelle's Bench channel momentarily when we transition over to the intermission in about 2 minutes. Again, all the light in this room is being powered by these coils, these 2 coils with radiant energy. Thank you, Crypto. Thank you, Pictures in Motion. You guys are the best. I appreciate everything from chat, all the new members. You guys are the best chat anybody could ask for. I always emphasize the chat is the most vital member of our team for the Fringe Science team, the think tank that Nathan and I put together. And this is all because of that think tank. This device would not be here today. None of this would be here today without Nathan. So we have to give him a huge shout out for the guidance and also the 3D printer to make this happen. All right, this would not be possible without Old Man Bill's Nathan. He has been vital to the development of free energy devices in general, and the dissemination of the science behind it. And it's not that complicated. You don't need a PhD to understand this stuff. You just need a tenacious effort to learn, right? You just need the will to want to learn how these devices work, and it's pretty simple. Basically, right now, we're just utilizing the back EMF from these collapsing electromagnetic fields being generated in the coil. That's it. Alright guys, I'm going to head on over to address any questions in chat while we transition to the intermission screen and get ready for the main show, the League of Extraordinary Inventors, right here on Beneficence TV. Stay tuned.
In the depths of hidden files, trapped inside the secret circuits, unraveling through the miles. Oh, truth was masked by coded curtains. You didn't know, we're shattering the silence. Feel the power, revelations on the rise. The shadows, light emerges, breaking through the veils of dark. 0 points and gravity converge, yeah. Guiding voices, revelation start. Ancient whispers call, they're begging us to open our eyes. We stand tall, defying all their lies. Even in now, we're shattering the silence. Feel the power, revelations on the rise. Forbidden knowledge we dare to see, unveiling secrets, setting minds free. In this epic, we play our part with fierce hearts. You didn't know, we're shattering the silence. Feel the power, revelations on the rise.
In the lab, Jones working night and day. Mystic gadgets in magnetic ballet. Circles of power aligning destiny's way. Running those rings, they defy gravity. Critics working out, they don't bother heat. In this domain, Jones sets the world free. Lord of the Rings, pretty strong. Proving the currents if you're wrong. Electromagnetic symphony. Terror only crash destiny. Free electronic cheat from his fingertips. Inspiration starting top of scripts. Geometric secrets, this country can't flip. Look our king in his rebel stead, building up for the world again. Lighting up the dark, igniting every zen. Lord of the Rings, really strong. Proving the currents
can't be wrong. Electromagnetic symphony, terror only grasps destiny. Lord of the Rings, really strong. Moving the curve and be wrong. Electromagnetic symphony, terror only grasps destiny.
In base lab alone with my mind. Stable theories they all refuse to find. I've been working on energy for a brand new day, but even in the crowd I'm still a castaway. Alienated from the A's of that inventor in disguise. Ideas ahead of time dismissed with narrow eyes. Benefactor boy, dreaming about the world you can't deploy. Changing the system, but treated like a toy. Ideas misunderstood, but brilliance is his boy. Benefactor boy, can't you hear his voice? Talking love 0 point, the points lost on them. Chemical structures crumbling from the same old sim. They laugh like I'm crazy, but I see it all so clear. Exploited labor, unheard injustice, burning ears. Fighting for a change in this wasteland of noise. But they call me foolish, why teach and boys? Benefactor boy, dreaming about the world you can't deploy. Changing the system, but treated like a toy. Ideas misunderstood, but brilliance is his boy. Benefactor boy, can't you hear his voice? Chasing revolutions in the darkest nights. A dreamer with vision beneath the laughter and noise. A future so bright waiting for the right choice. Benefactor boy, dreaming about the world he can't deploy. Changing the system, but treated like a toy. Ideas misunderstood, but brilliance is his boy. Benefactor boy, can't you hear his voice?
Majestic moments in cosmic flight, holding on to the stars of starlight. There's a light within the dark waves, guided by echoes of ancient ways. Unify our reflection, with everything there's a connection. Feel the pulse, divine sensation. Everyone feels the goodness of our invitation. There's a light within the dark waves, guided by echoes of ancient ways. Unify our reflection, with everything there's a connection.
Again, I have to mute the intro video, guys, because of the music, but it will be unmuted in a minute.
Good evening, everybody. Welcome to League of Extraordinary Inventors. I'm your host, Mike from Faraday Research. It is Free Energy Fridays. It's Friday night, January 24th, 2025. Welcome to the show. We've got our regular panel, Nathan, Lulu, Philip, and the Benefactor. Welcome to the show, everybody. Live chat is open, so feel free to shoot us questions and comments. I'll be posting them on the screen as we go. And yeah, it's been a busy week. It's been a very frigid week, like minus 30 on Wednesday. It was the coldest day of the year here in Toronto. So
was this minus 30 in Toronto?
Yeah, Wednesday evening hit minus 30 with the wind chill. It was minus 20 and then minus 30 with the wind chill. So it was cold, like really cold, like cold that hurts. That's how it is. But
Nice.
it's getting better. Temperatures rising. That's a good thing. It's not so painful.
Yeah, but we're not done with January yet, so
Yeah, another week in January. And, well, we'll see how it goes. February is kind of the turnaround month for us, anyways. You might get the odd blast of snow, but sometimes it ends early. Like last year, it was like first week of March, and like things were already melting and everything, and it seemed like we are gonna get it like an early spring. So, but hopefully spring comes soon. That's all I gotta say. I can't wait. It's been a busy week. I worked on my brand new crystal cell, and I actually have that video posted on my YouTube channel at Faraday Research if you want to check out that. Nathan's been working on a few things this week. I watched a few of his videos. I really like that thing with the pop can. That was really cool. And he's going to talk about that more. I know, Philip, you have something really big to show us tonight. And Lulu, hi Lulu, she's here in the car again. She's always driving when she does this.
Almost home.
And Ben, I don't know, what have you been up to lately other than working on the jewel theme?
So we have a full working prototype of the Lightning Thief Jewel Thief device, but we also have the Lumen lamp. So I'd like to show you guys the Lumen lamp, which is really, really nice.
Yeah, if you want to do the screen share, we'll pop that up.
Yeah, give me 1 second. I actually have a video I can show you guys that I didn't actually show on the presentation earlier for the pregame show. For those watching, I do a pregame show for the League of Extraordinary Inventors to go over more details of my research, just because I know like there's a lot of people on the team and I want to be respectful of time. Just to make sure, like, you know, we can go over some of those details that we might not get to on the main show. So I have a video that I didn't get to, or I forgot to show. Let's see.
Yeah, live chat is open, everybody. Any questions, comments, you can put it in the live chat. All right, so I'll put this up.
Okay, here's the MJ21194 transistor at 400 milliamps, or approximately what the other limit was. We'll compare brightness and decay rate. So there is a swappable transistor on this board. So I'm comparing the two transistors, and I have another quick video to compare that transistor to the MJE13009 that I've been using mostly. This is the transistor that Michelle has been working with. Let's see, remove that. I'll bring up the other video. Okay, so this is 400 milliamps with the 13009. You hear it ringing. Oh, so this is 400 milliamps with the 13009 transistor. I don't know, it looks slightly more brighter. The dial can go up to 3 o'clock or a little bit past 3 o'clock, whereas before it would turn on around 6 o'clock here, and the 400 would be around somewhere the 9 o'clock. So for the equivalent here, we'd be around 9 o'clock, and this is around 3 o'clock for this 13009 transistor. So obviously it's going to change the rate there and the resistance, but we're using the fusion coil. It is a designed by Michel Morel, and we also have a the base itself has swappable coils, so we can utilize another coil that he made, which is the caduceus coil.
Yep, very good. Looks good, man. Oh, yeah. Did you get my email? I sent you my mailing address, and let me know too if how much the shipping is, and I'll.
Oh yeah.
Or whatever.
For sure. Yes.
It shouldn't be too much. You're in Michigan, and I'm in Ontario, so it shouldn't be that much.
Yeah, and it's going to be a small package, so I just want to make sure it's like.
I probably would get it within a couple of days.
Yeah, yeah, and I'm hoping that it'll be fun for you guys to try out. I have a whole instruction manual and all that stuff.
Well, what I like to do is my cells I've been working on. I like to hook it up to your Jill Thief and try it out with that.
Yeah. Yeah, no, there's a whole host of possibilities. I'm sure you guys will come up with all sorts of things that I didn't even think about. So, yeah, it's fun, and we have the board. Oh, let me pull up the image real quick, because I'll show you that. Okay. So let's share screen. And we'll bring up, this is the board, and you see all the screw terminals. So these are all the swappable components, or, you know, the jumper cables for all the wires, so you can easily, you know, modify the board to customize it for your needs. You know, because not every coil is made a little different. You know, you guys might not be working with the Abha Rodin coil. You might have some other kind of interesting coil design that's bifilar that you would like to do.
Very cool.
And just interesting thing to keep in mind, the you see this, it's the screw terminal, the 3 screw block at the very right of the board, in between the two, one on top and one on bottom, the two. So that is for the capacitor, and that middle one is basically not used. So we're just using the 2 ends, and that's the only thing I needed to emphasize. For the capacitor, it's just the 2 end screw terminals. We're not using the middle terminal, obviously. So I couldn't get it to fit with just the 2 block. But yeah, it's easily, you can swap out the neon for different colors, or if you have different, you know, say you have a coil that's really powerful, you can put a higher rating neon lamp on it to protect your transistor, you know, or, you know, if it burns out, like mine did, I accidentally disconnected the load, and the neon lamp turned on and kind of burnt out after a while. So you can swap it out, and I'll include an extra neon lamp or 2 for you guys.
Yeah, it's one thing with those circuits, Ben, you can never run them without a load. That neon is kind of like a protection, but if your system's super efficient and puts out a high voltage, even that lamp will burn out on you. So you might even want to hook up 2 of them, because usually those neon lamps are rated at 90 volts. So
see, this is the type of thing that this is the type of thing that we need to consider for practical applications. Yeah, because as I noted earlier, it's just there as an indicator of resonance. Really, it's an indication light. It's not meant to be on for long periods of time, you know. But I will be also including 2 different transistors, the Charmander and the Squirtle. I don't know if you guys were following the pregame show. I got tired of saying the long name for each one. So but the MJL21194 Bedini recommended transistor that Michelle is using, that's what Squirtle is. And then the one I'm using is Gerald's 13009, which is Charmander. And I'm saving myself a little breath.
Hey, Ben,
Yeah.
put a switch on that neon on the negative side, just in line with it, and just put on there that it's used for startup testing, and you'll save the light while it's running, but it'll turn on during testing or during checks.
That's a good. I'll write that down right now because that's good. I like that. I need all these tips because I mean the device works, but I want it to be like perfect. You know what I mean? I want it to be better.
Yeah, that'd be cool.
Yeah, it'll take a while to develop it, right? But
Yeah.
I think you're on the right track. You got a good partner to work with. He seems to know what he's doing with it. So,
Oh, he's an absolute genius. He's an absolute genius. I have a hard time keeping up with Michelle. But you know, we're gonna have some kind of, you know, crude Gen 1 out, hopefully at the end of the year or early to 2026 at the very latest. So well, we should be able to get some kind of crude Gen 1 out for the people that want it. And the lumen lamp, I don't have any date on that at the moment. That's, you know, I don't have any release date for that one, but it is open source, and I'm going to be putting the 3D files that are already available on Michelle's YouTube. I'm going to be putting them on my Patreon for free subscribers. So not behind a paywall, but you know, if you're on my Patreon, you'll be able to download it as a free member.
nice.
But he already has that link. Yeah, and he already has all that information on his channel anyway, so it's all in the public domain. You know, we're not keeping anything behind a patent. If you want to build it right now and you have a 3D printer, you can go and build it. So,
Yeah, that's good. That's awesome. Philip,
Ben, real quick, Ben, if you need the light in order to adjust the frequency or something in the circuit, and when you do a switch, have it go to a small cap instead. Like you can switch back and forth, so you get the light when you want the indicator, and you get the cap when you turn it to the other side. That way, you don't lose the load.
I like that. No, that's a good idea, and that'll be a good consideration for like a version 2 PCB. And also, I forgot to say that I'm going to be including a second PCB. If you guys didn't catch the pregame show, I'm going to be including a second PCB in with the kit for you guys, in case you want to build another one and, you know, utilize the dual thief setup that I have, or, you know, just have an extra one.
Cool.
So you'll have that extra
Awesome.
PCB.
Hey,
in there,
Ben.
yeah.
I sent you a Tesla website. I don't know if it's helpful, but I just thought it might be useful for you, like for you guys in general.
Yeah, I took a peek at it. There was some really cool stuff on there.
Yeah, cool.
I didn't get to look at it too extensively though, but there was a magnet motor of some kind on the front page, right?
Yeah.
Like a spiral magnet motor. Like the magnets were in a spiral configuration. It was interesting.
Yeah, I'm not a coil expert, but hopefully that helps.
I'm still waiting for Nathan to
Yeah,
make a
thank
pulse
you.
motor.
To make what?
I'm still waiting for you to make a pulse motor.
I'm getting there, man. You know, I got to finish up my Tesla coil research, man, and then I'll start, because I definitely need it for the next phase when we start to run the motor on the last circuit. Well, I'll get into it later, but I'll definitely need it.
All right, Philip, you're up.
Yeah, so tonight it's historical, man. It's yet again, it's a historical show. I posted my Patreon link if you want to post it in the general chat, because I am on the right track without any doubt on the quantum level, and this week is earlier this week I figured something, and I couldn't wait to share it with you guys tonight. So I had to wait all week long for that. It was painful. But I'm gonna start with standard stuff first, and I'm gonna end up with the cool stuff. So just one sec. Entire screen. So I'm gonna start with my little intro I created. So yes, sir, that's my finite theory intro, and here's my simulator again. But here I'm showing off paraparticles. These are particles. These are fermions that don't have the Pauli principle. So that means they're kind of acting like normal matter, but at the same time they're acting like light. They don't have the restrictions of normal matter, so it's kind of a matter that can easily morph into other matter. That's what it is. So it's not following the restrictions of the normal matter, of the Pauli principle, as they call it. Pauli principle is it restrains the electron orbits and the number of electrons per orbits and all these conditions. But the paraparticles, they were discovered actually this week, and they were confirmed. They were hypothesized earlier this century, but they were confirmed this week or last week. And yeah, it's pretty cool. It's like matter that can morph into other matter. So it's something to follow up. And now the cool stuff. So this is the Feynman diagram that represents an electron and a positron smashing together, and it creates a photon. So I put it some thought. As you know, regarding finite theory, photon has a mass because energy is mass. E equals mc square, and the you can change, and the speed of light is a function of the frequency. So if you increase the frequency, you're gonna increase the speed of light. This is confirmed by the explosion of the supernova, some supernova explosion that exploded a long time ago, and some galaxy far away, and they did measure a difference in time for photons of different colors. So if you have a specific color, if you have a blue color, it's going to travel faster. And if you have a photon of red color, it's going to travel slower. So, and there's a difference of a few seconds. They say that it's they don't want to admit that speed of light might differ, but it does differ. And so that's one thing I want to mention. And the other thing, I want to guys make you think a little bit. So the electron has an energy density. The positron has the equivalent same energy density, but yeah, the negative. The electron has a negative energy density, and the positron has the equivalent positive energy density. So when the electron and the positron are smashing together, the photon has a null energy density. What happens to the energy density? Where is it going? Little question here. Trivia. Anybody?
Where the energy is going?
What happens to the energy density of the electron and the positron when they collide together? Because the photon has null energy density.
Well,
Because
it would basically hit center and then bounce back out. It would be a deflection, wouldn't it?
yeah, there's a deflection, but it's kind of in the middle. But I'm really talking about the scalar energy density. So you have the electron has a negative amount of electric energy density, and the positron has a positive amount of electric energy density, and the photon has a null energy density. So it's not respecting the conservation of the energy. And I don't know if you follow what I'm trying to say here. What happens to the energy density? It just disappears.
Would it go into counter space, I guess?
Yeah. So here's my explanation to that. So you have the electron with a negative electric energy density, the positron with a positive electric energy density. They smash together, and you have a photon with null energy density going at the speed of light. So the energy density is converted into kinetic energy density, energy. So that's what happens. There's no loss of energy. It's just transferred into kinetic energy. So that's
Kind of like
that's my explanation.
So would it be like a kinetic shock wave?
Well, kinetic energy is like just like speed, half mc square, mv square, sorry, dot, 1/2 mv square. So that's the kinetic energy density. So it has to do with the speed, the speed squared and the mass. So that's what happens. The electric energy density is converted into speed. So there's no loss of energy at all. And C represents the amount of electric energy density of an electron and a positron together, because that's what the photon is. A photon is an electron and a positron entangled together. So yeah, man, I figured that out this week. It explains everything. It's the root of pretty much everything right there.
So that field can only collapse to like a 0 point, and then it has to reflect back out, and that's where the kinetic energy is.
Yeah,
right?
exactly. So the electric energy density is converted into kinetic energy.
Right.
So there's no loss of energy.
Right. Because in essence, it's kind of like hitting the blotch wall, like in a coil. When the field collapses, it collapses towards the blotch wall, and then it deflects back out, and that's what we call a back EMF, right? So because it can only collapse so far before it has to stop, because there's no other place for it to go. Well, we know it's not going into counter space because the energy is coming back out, but it's actually, there's more energy coming back out. So that begs the question, is that how you're tapping into 0 point energy? Is from that deflection, the kinetic energy, coming back out? I don't know. Correct me if I'm wrong.
Yeah, it's just I'm not tapping into 0 point energy. It's just the energy is being converted from one one format to another one convention to another one. It's just the electric energy density is converted into kinetic energy. So, but I mean, if you talk about 0 point energy, you can say that you can do the opposite. You can convert photons into electrons and positrons, and that already happens with the pair production. But you could maximize the pair production. You could create an electron and a positron out of a photon of high frequency, but you could create both of them if you have the technology for it. So that's some sort of 0 point energy if you can convert light into electric energy.
Yeah,
But-
well, it seems like there's a lot of similarities between what you're talking about and what happens with a coil.
Yeah, you're the coil expert. You can tell more about it, but yeah, man, it makes a lot of it makes a lot of sense, and it's mathematically perfect, and there's no loss of energy. The just one form of energy is converted into another form, and speed is a form of energy, and that's what I want to share. And
Yeah, it makes total sense. I see a lot of similarities there.
yeah,
Between
exactly.
the type of energy we're working with, a coil with a back EMF, and the collapsing of the field to a blotch wall. Even when you're getting down into the particle physics like what you're doing, it's basically the same thing, just at a different scale. You're down in the quanta, right?
Yeah,
So your theory is based right at the fundamental field theory, and also scale. It's about as small as you can go.
exactly. And
Eric Dollard also made a comment too. The speed of light, the way we use the speed of light, it's an arbitrary constant. He says it's not a constant, it's arbitrary. But we use
yeah,
the
it's
speed.
a speed of light is a function of the frequency, and the frequency is because the electron and the positron, they don't have like a perfectly always the same amount of energy. So if you collide a weak electron and a weak positron, then it's going to create a weak photon with low energy. It's going to travel a little bit slower than an electron, a photon of high energy. So these are not they're not like hard coded constants. And but yeah, my main point is the amount of electric energy is being converted into kinetic energy,
An
and
actual
that's
kinetic energy, which actually that kinetic energy can influence actual matter, and actually influence that matter.
kinetic energy. It's yeah, so you could, but matter is more like particle. And I'm talking about fundamental subatomic particle,
Right.
the smallest particles. It's easier to understand. It's like in computer science, we always say, keep it simple, stupid,
Yeah.
So that's as simplest as you can get to understand fundamental stuff, and you start from there. But at the particle level, the matter and things like that, the problem is you have like the neutron is neutral, but it's constituted of multiple charged quarks. So the sum is null, but it's it's composed of it's composed of positive and negative quarks. So it's not exactly the same thing. It's like on top of that you're gonna add particle, but subatomic particles. That's what happens. You have photons are composed of are an electron and positron entangled together, and the standard electron is just and the positron is just a form of energy density that is converted back and forth into kinetic energy. So that's and other things I wanted to say also is again they make quantum mechanics very complex, and they overcomplicate it, but it's very simple to understand. They use words, they use fancy words here and there, but it's very simple. Like they use the term color charge for quarks. Color charge. What the hell is that? You know, a charge is not. It doesn't have any color.
Yeah, they invent all these new names to make what they're talking about sound very intellectually advanced to impress academia to make them.
Yeah, exactly. But a color charge, all it is, it's a fractional charge. It's like 2/3 of a positive charge, or 1/3 of a negative charge. That's all it means. That's why are they inventing all these fancy stuff? And the other thing is, you have the color charge and the electron flavors, then the flavors of positrons and electron. You know, you can't taste an electron, so why are they calling it this way? All that it means is that the electron and the positron might have variant masses. That's all that it means. They don't have exactly all the same mass, so they have different flavors. But you know, that's the thing. They use fancy stuff, but it's very simple to understand. And yeah, so the only thing left I need to understand is the Pauli exclusion principle. Because you have a set of rules in an atom that follows Pauli exclusion principle, like the number of electrons per orbit, and the energy levels have a different number of electrons per orbit. So I just need to understand that, and I'll be pretty much done with quantum physics already.
So after this, you were doing some lab experiments, or do you have anything on the go with the lab at this time, or?
The lab, no, I just need to pay my bills, you know, with
Yeah.
I still need to pay my bills, so I'm gonna start I need to pay lawyer bills from last year. My taxes and a whole bunch of bills. It's pretty crazy. So yeah, that's why I posted my Patreon links if anybody is interested to help me out on my cool research that I'm sharing for free. That I cannot publish because it goes against Einstein and all that. So it's never gonna get published.
Bill, you
But
need to
you-
explain what your research can lead to. So, like, tractor beams and stuff like that.
Yeah, explain the possibilities. If you don't explain the possibilities, people think it's only little dots that are going in circles. They don't understand what that means.
Yeah, tractor beams. It's pretty easy to create already using any beam of high energy density, of any beam of light or magnetic, electric, gravitomagnetic, or gravitoelectric beam will create a dense energy density that will freeze anything within it. So
That's so awesome.
yeah, it's already possible. Same thing with force fields. I already shared the idea of the force field with the Missile Defense Agency. All the maths, I give them all the maths under a confidentiality agreement.
So the say for an example, the force field based on your physics that you've come up with, what would be the effects on the human body? Is there any kind of ill effects with this? Is it something that the human body shouldn't be exposed to this for whatever
No,
reason?
it's perfectly safe, but it's not gonna affect humans. It's only gonna affect metallic objects like that can have electrons and like electric charge or something like that. But it's not gonna affect the human body. It's
That's good.
possible to create a real force field that will block humans, but you'll require like an astronomical amount of energy for that using the gravito-electric forces. You'll require astronomical energy, but for metallic objects like missiles, bullets, and everything, things like that, um, it's pretty easy to create an electric force field. Electric force, electric force field, yeah. But it's not like you're not gonna get buzzed by a lightning. It's like a real force that will repel the the missile or the projectile. It's an extension of the strong atomic force actually. So the strong atomic force, the force field, and the black hole, they're all the same thing. So see, I don't have any limitation
That's so
on any
cool.
scale.
So it's
So
like an
they-
anti-missile barrier, like it's it's an anti-missile defense. Uh, what do you call it? Field. Like, yeah, it's a field.
Yeah.
Yeah.
Yeah, so the all missiles are made out of metal, so and bullets, so you can block them all because they're easy to ionize. You need to ionize them, but they'll get automatically ionized actually. So they and as soon as they ionize, they're gonna get repelled. So
Yeah, that's
Do you
awesome. I know you have
do
a
you think
video. I'm sorry.
no, go ahead. Go ahead, Ben.
I was just gonna say he has a video where he shows like the light attracting something, which is really really interesting.
yeah, I did a presentation on APEC like 3 years ago, but I had a cool presentation with computer animated stuff. I work on it to so that people understand easily. And but it's a long time ago. But after that, I got sidelined by APEC. I don't know why, um, but maybe I can do my presentation here. I can do my computer animation and just present it here at some point, so you guys can have
Mm.
a clear visual picture of what I'm saying.
I'd love to
I'll
see
do it.
that.
Yeah.
Yeah, definitely. That would definitely make things more clear so we understand exactly how your theory is working.
But yeah, it can be scaled up from the quantum level to the macro scale level. So so yeah, I don't have any limitation. That's the cool thing. And
And you
so
said, didn't you say that your force field technology can also be downscaled to be like a personal force field as well?
yeah, it can be scaled easily at any like the electric force field can be scaled easily with some amount of current, some a minimum amount of current. But if you get there's a sweet spot. If you get the current, it's gonna create a sweet spot. If you get the right amount of electric current, then at some point you'll have the repelling effect. So
Phil's gonna turn into Iron Man.
yeah, it's like you need like you need to tune the current to the not the correct frequency, but you know what I mean, to the correct amplitude, and you're gonna get a repelling effect.
That's
So
awesome.
But does
That's
that
so
require when you increase the amplitude like that, does it the amount of energy to actually do that, goes up exponentially higher, right?
so
To get a
sorry, say
higher
that again.
to get a higher amplitude, what you're talking about, to get those repulsion forces, the amount of energy used to do that has to be way, way higher.
Yeah, there's there's a sweet spot. If you have too much energy, you're gonna lose the force field, the strength of the force field. If you don't have enough, it's gonna do the opposite effect. But if you got the right current, then you can the right distance, then you're gonna have a repelling effect. And the
Is it the idea of like, have you seen the movie The Dunes, where they
yeah
press the little button and then they create a field, like they can't get harmed, by anything, like any instruments or any weapons or anything. Is it something like it creates like a field where it's like a protective field?
yeah
Is that your idea of something like that?
yeah, but my goal was to protect like fighter jets and military equipment, but it can be applied for human as well.
No, because you said it could be scaled down, so my mind was
Yeah,
just thinking on,
yeah, it can be
like,
scaled at any level.
very cool, very cool,
Yeah,
very cool.
and there's a true force field that repels everything are possible as well, but you just require like the amount of energy of a black hole or something like that. But so it requires much more energy, but maybe it's possible at some point to have that amount of energy if we can create a Dyson sphere and collect energy in a capacitor or teleport it, something like that. Um, it's definitely possible. So so
Now,
yeah,
can you get the same effects if you're using negative energy, like a field collapse? Is there, or am I totally off on this? Can you get more energy by collapsing the field?
um, you mean a field collapsing that it collapses and creates some sort of shock wave, or
Yeah, yeah. Because
um,
because when it collapses, it can only collapse to the blotch wall. So the energy's got only one way to go, is out. And if it's hit hard enough, that would create a shock wave going back out, created by a negative energy spike to the blotch wall. And then when it hits the blotch wall, it can't go any further. It has to go back out this way. And that'll
yeah,
create a shock wave. I could be
yeah,
totally off on this.
yeah. It's on top of that,
Is it like pulsing? Is that what you mean, Mike? Like a pulsing kind of thing? Like,
Yeah, like an
on-
impulse, like an energy impulse, like
Okay.
what
Yeah,
Tesla
no,
was doing. Yeah, it's an
yeah, no,
impulse.
it's a little bit different from Tesla. I know. I remember. Well, I saw what Tesla was talking about at some point, but I forgot a little bit. But um, no, my force field is not pulsed. It's constant. It's continuous. Continuous electric field.
Yeah.
That
So a continuous electric field like that, Phil, you're going to need enormous amounts of power to do that.
No, no. It's pretty decent. It's like 200,000 amps or something like that.
200,000 amps.
Yeah,
A lot.
That's a lot of juice.
Oof.
Yeah, but with
Oh, baby.
low voltage. But I mean that's for a fighter jet. But
See, like
for human,
Tesla, like some of his Tesla coils, they were creating 2,500 amps at 3 million electron volts. That's a lot of juice right there.
yeah,
So yeah, like you're going off the charts.
yeah,
Yeah, cooks a pilot like a hot dog.
Whoa,
yeah,
just be instant flashbang.
Yeah.
yeah. So
Wow. That's a lot.
yeah, but it's low voltage. It's all about the current, so it's not necessarily
Yeah, so
it's
you're
gonna be
using brute force currents. Yeah.
yeah, yeah. But I'm just saying it's possible. I reviewed my maths a million times, and it makes a lot of sense. I wish I could share them right now, but
Like
um,
what you're talking about, if you were to actually create this kind of like a shockwave or even like the force field that you're talking at with, using, how many amps did you say again? 25,000 amps?
200,000.
200,000 amps. You're
Yeah,
go- you're gonna you're gonna you're gonna warp um, time with that.
yeah. That's the idea. It's that's it creates a repelling. It repels because of the time dilation. That's exactly what it is. The
Yeah,
same thing with black holes. If you cross the even horizon of a black hole, you're not gonna get transformed. You're not gonna get spaghettified like Stephen Hawking was saying, and the mainstream is saying. You're gonna get repelled if you cross the even horizon. The force
Mm.
is gonna flip. The force is gonna flip over, and you're gonna get repelled from the center of the black hole. The same thing. That's a force field right there.
yeah,
So it's the same thing with the electric force field, just at a smaller scale.
yeah. John was saying use the disk generator, the homopolar generator that Michael Faraday made. Um, I made an end machine like Bruce De Palma. Now it only created about 250 millivolts, but it was cranking 30 amps, right? So
Yeah,
that was the magnets were only 3 inches in diameter. Spin that up 4,000 RPMs. I was getting 30 amps of power, but the voltage is so low. It's only about 250 millivolts. But yeah, I was cranking a lot of current with that little machine.
sorry, how many amps again?
30 amps,
30 amps. Can you crank that up
whatever you want.
10
1,000 amps?
million.
Well, if I say had a 6-inch diameter magnet and spin it at 4,000 RPM, I'll probably get 100 amps.
Oh,
Right
cool.
there.
Okay.
That's-
Faraday motor.
Yeah, the Faraday disk or the homopolar generator. So,
But by the way, copper going into a magnetic field will stop.
yeah,
So if the bullets are all copper, then
Yeah.
if you have a sufficient magnetic field, the bullets will just stop and the
Because-
speed of the airplane will deflect them. So you may not need as many amps as you think you do.
yeah, because that creates eddy currents, right? So if you're using a copper disc and you spin it at that high RPM, and you got a magnet spinning with it at the same speed as that's spinning, now you got these vortices going around the disc on the outer diameter. Those are eddy currents, and what's going to happen? That copper disc is going to heat up. You're going to get heat.
Yeah.
So not only are you going to get heat energy, you're also going to get a huge amount of eddy currents. And yeah, Nathan's right. If you were to fire a bullet at it, it would stop dead in its tracks just by
Right.
the eddy currents.
Yeah. Interesting. But yeah, I'm a fan of big currents and low voltages. So it's it's even applicable for my anti-gravity experiment as well. These high currents, low voltage. But yeah, so yeah, again, remember what I told you? It's this. I just explained to you why the speed of light is c. It's proportional to the energy density of an electron in a positron that is being converted into kinetic energy. So yeah, so there you go.
See, like,
There's no
see, Bruce De Palma, when he made his machine, on the axis of the machine, on the where the magnet spins on the axis, he put a standard analog clock, and he spun his up to, I think he said around 8,000 RPM. He started getting time dilation. The clock started slowing down.
yeah. That's because the energy density fluctuates because of
Right.
the gravitomagnetic field is generates.
Right. I'm just gonna zip out for a quick smoke, guys. Just carry on.
Two.
Yeah. So
Very cool. Very cool, Phil. This is like really cool. It
yeah,
has.
I woke up one day and I just figured it out, and I'm really happy, and I'm happy not to be a mainstream PhD in physics, because if I said things like that, I would lose my job or destroy my reputation. So I don't have anything to lose. So that's the cool thing. I can say whatever I want.
Yeah. Well, you know what? You may not even need it for a lengthy amount of time. If you can track the bullet and you could turn it on quickly and then deflect it, you know what I mean?
Yeah,
you don't need it
exactly.
on the whole time.
Yeah. So that you change, speed is meters per second.
Mm-hmm.
So if you change the time factor, then you're gonna change the speed, because speed is the denominator of time. Time is the denominator of speed. So you will affect the speed and be able to deflect the projectile.
You need a
So
second component, though. You need like a static field in there to have the counter to make that time dilation work. It won't work with this one field. You need both.
field of
It's got a cross mesh in
no,
order
you
to create.
just need the electric field in a certain amplitude and distance. You will have a repelling force for electric objects. Well, objects that can get ionized, like metal.
I understand the deflection. I'm saying it's different than the time dilation. The time dilation would require both.
I would think that you're right. You need both. You need the deflection and time dilation in order for it to work.
Well, no, it's you have to build both fields in order to create the time dilation.
What both
You
fields?
need a high voltage field and you need a high amperage field. And between the two, you can create the time dilation. So if you could switch it quickly enough, you might be able to create it with one unit. But you need both. It's like a counter field that doesn't let anything through it, that's able to slow time or stop it.
Well, the amplitude, because all I care is the electric field that comes out of the wire. But if you check the equations of a electric current in a wire, I think it's just proportional to the current.
Okay. But the wire doesn't create the time dilation. The wire creates a deflective force.
Yeah, the energy density will. So yeah, man. The future is all about high current. So let's all work on that and get the kiloamps. The kiloamps.
Well,
about
Tesla talked about cold energy currents, which I don't think he meant like, the weather in Canada currents. He's talking more like room temperature and like 10, 20 degrees below, but the currents don't have the same heat effect. You know what I mean? They're cold, but they still have massive currents, which you could flip in an instant and instantly flip back.
Okay. So you call that the cold current?
Yeah.
Okay.
That's what Tesla was talking about. He did negative radiant energy, converted fields, and that way it's safe. And then until you want to create the heat, and then it's instantaneous heat. I don't know that the aluminum would put up with that in an airplane. If you created, was it 2,000 volts of DC, 2,000 amps? Isn't that enough to melt aluminum like within seconds?
Oh yeah, that makes sense. So you need a titanium wire or something like that.
Yeah, you need just something that changes it.
Yeah. So yeah.
Find us a diamond on the outside so we can burn the living daylights out of it. You know what I mean?
Yeah.
That'll withstand some heat.
Yeah.
Crazy thing is it'll withstand some pressure too. So that might be like the perfect substance to you get a diamond plane. That'll cost you forever. No, but I'm just saying you need some kind of material that can withstand all of it. If you're going to do that.
Yeah, good point.
Graphite.
Can it withstand 200,000 amps?
Yeah, I mean,
what about graphite or graphene? Doesn't that withstand a lot of temperature?
Dude, 200,000 amps touching, I don't care if it's a rock. That thing is like dust. As soon as it touches it, it's completely vaporized. Like we just got hit with a Star Trek laser gun, whatever they call it, a little plasma weapon
or something.
The phaser, yeah, we got nailed with a phaser in a second. That's what happened. Everything goes to dust.
So what
we'll have to bring down the current quite a bit to get your deflection in order to work it properly. But yeah, because I've seen them, like they take this giant magnet, right, and run this copper right to it, and it stops dead in its tracks. So it might just be that you permanently change the actual plane so it runs like a magnetic field. So all you're doing is creating an electric when you make a magnet. So just do the same thing with the plane. Make it an instant electric. That way you don't have to worry about the currents, but you get the repulsive field.
Okay.
You're permanently putting a field into it. You know what I mean? Just like you would a magnet.
Yeah. But I know about it's gonna repel, but it's just that the amplitude, the strength of the repelling force. In my case, it's way higher. If you get the sweet spot, it's not just two magnets repelling each other or things like that. It's very like two magnets time 300, something like that. Because of the time dilation at low distance, the strong nuclear force is like 300 times stronger than the normal electromagnetic force. So it's about the amplitude of the force that I'm trying to maximize.
No, I understand. I'm just trying to figure out a way to build it.
Yeah. I wish I could share my equations with you, but maybe I will at some point. If maybe I'll make everything is kind of. Actually, everything is kind of public already, but if you guys can connect the dots, you can't figure it out. Everything is out there, but I just want to make it difficult for now to connect the dots. Maybe I
I
can
get
make
it.
some. Maybe I can, because I already sent the whole solution to Missile Defense Agency. We'll see if they're interested, and I'm pretty sure they will. But trying to make money out of it,
I get it. Well, make what you can. Go for it.
Yeah.
I would think it has something to do with the charges, like, flipping the charges, that, where it, like, two negatives would repel, two positives would repel. If you do that, you could create a field, like a barrier, just by the charge of the atomic particle. So
Yeah, I forgot to. I think I showed this article before, but I'll show it again. Just one sec here. So I'll show it right here. Loger d'écran, window. You got the tab, light chargers, a track. Yeah, this tab right here. It's already it's already observed in a lab in March 2024 that light charges can attract and opposite charges can repel as well. So they can in a certain substance. That's because the substance is altering the linear charge density. So the linear charge density will change the behavior of the electric forces. But it's already observed that that light charges don't always repel, and there's something weird there. So it's already observed in a professional lab, and I also posted. So we assume that an electron will always attract a positron, but it's not always the case. Sometimes they repel. So that's a little bit what my force field is doing as well. I'm kind of harnessing this effect. I'm kind of harnessing this effect, and I saw a comment saying, "Phil, you should start experimenting." But I posted I started experimenting a long time ago. I added links in the private chat. Maybe Mike can share with the public audience here about the magnetohydrodynamics and the grinder experiment I did a while ago.
Yeah.
10 months ago, actually. So yeah, that's obviously it's not free, but if you guys can pitch in with my Patreon link that I posted, that would be very appreciated. And again, tonight I'm telling you, it's like I don't want to brag, but I don't want to go to the APEC open mic anymore, because dude, they sidelined me once. They're not gonna sideline me twice. So, but if I could go there, I would crush. I would crush all the PhD, including Jack Sarfati, in 5 minutes. They're not going to be able to say anything. I swear to God, it's very clear in my head. So
I'm still waiting on him to go to Russia.
yeah,
He's like, the Russians invited him, so like I've been hearing about it for a year now. It's like, okay, when are you gonna go?
yeah, but I don't want to start a war with him, because he's a friend of a close connection of mine, so I don't want to mess with Jack Sarfati. He's ultimately he's a nice person, but he's just a little bit arrogant. But ultimately apparently he's a nice person. So, but I'm telling you, if I'm forced or if I have no other choice, then I can't just go there in next month and crush them all in 5 minutes.
Very
Because
cool.
Did you hear that NASA was building a new engine based on the hydrogen engine, the water splitting? You know,
Are you serious?
yeah,
The electrolysis, high temperature electrolysis.
yeah, they're building
Oh yeah.
something now. They're trying to get credit, like, oh, they invented something. I'm like, this is Phil's invention. This is
Oh my god.
But
Those
yeah,
guys have been
Phil,
working
at
on
least
that for years.
at least you know you're on the right track though. If people are stealing your idea, you know you're on the right track, right?
Even the energy teleportation, I got this idea. I presented that idea last year at the Defense Tech Connect in Washington D.C. And now all of a sudden there's a company that does energy beaming.
Yeah. No, I've been in your situation, and you know, all you can say to yourself in that situation is they might be able to steal, you know, this or that, but they can't, you know, steal my mind, which created all these ideas. You know, you're gonna continue to come up with revolutionary ideas, whether someone's going to try to, you know, benefit off of it or not.
Yeah, exactly. And but there's a lot of the, there's a lot of countries in Europe. They just not to name specific ones, but they just steal ideas. And in Canada, the problem in Canada is everybody's sleeping here. I have all these ideas. Nobody want to help me, and or you have to go by contacts. You know,
Yeah.
the, you present your ideas, but nobody cares, or it's not about nobody cares
Yep.
because it's not about Putin or hockey or some things like that. So they don't care.
Yeah.
So you have to the way you have to approach them is saying, "Oh, I know this person, and why don't you know? So I'm part of this incubator. So why don't you guys help me out and things like that?" So you have to. It's like it's a you know that's the way it works. That's the way the Canadian government works. If you want to, the same thing with jobs. If you want to apply for a job there, it works by knowing somebody that already works there. But
Exactly.
it has nothing to do with merit. You know, that's one thing that pisses me off about Canada is it has nothing to do with merit. It's all about who you know and things
it's
like that.
all over the
So
place. It's not just in Canada. It's not what about you, what you know. It's who you know.
yeah,
This is everywhere. It's, you know,
yeah,
seriously, in Canada, like here, let's say in Houston in Texas, same thing. It's not about what you know. It's about who you know.
yeah.
And
It's not
unfortunately,
fair at
the
all.
people that you know are just pure idiots, and it's like I wouldn't even want to attach my name to them to begin with. You know, like I don't want that position if my name is going to be attached to, you know, these no brainers to begin with. So, you know,
Yeah.
I would rather do it the intellectual way, the right way, than, you know, the Miss USA pageant way. You know, seriously, like, you know, no brains, but just nah, no. I think what you're doing is the right way, and it's gonna pan out. And proof of that, I'm telling you, NASA's already stealing ideas. So
Yeah, yeah. There you go. So
yeah,
it's crazy.
yeah.
Um, but yeah. So the only thing I care about is the that. But I'm pretty confident the Missile Defense Agency will get back to me I signed a confidentiality agreement with them, so if they break it, if they come up with force field and they don't have credit for it, then sorry, but I will be I will be offensive, and I will sue them if that happens. But suing the U.S. government, how can a Canadian can you imagine how expensive that's gonna be? A Canadian citizen suing an American government agency, just people from the January 6th. By the way, some people got pardoned for the January 6th event a couple of years ago. They got pardoned by the current president. They didn't do anything, and they had to pay 100,000 of legal fees just to negotiate their misdemeanors. The misdemeanors, they had felonies that popped out of nowhere. They never did anything wrong. They had to pay $100,000 to negotiate it down to misdemeanors. So if you have to pay $100,000 just for that, can you imagine the amount of money I would have to pay to sue a U.S. government agency? Yeah, so I have no chance, but
Well, you got to find a lawyer that will take it on contingency. So whatever you make, they take a percentage out of it. So you
yeah,
really don't
that's what I
pay.
did in the past.
Yeah.
I know one that helped me out in the past. She did I won too, so she did a pretty good job, and maybe I can reuse her for that case. I don't know, but she was pretty good. But yeah, that's a good point.
You have to find a lawyer that is passionate to doing the right thing, not for the money part, but more for the principle part.
Yeah,
And usually the ones that, if you would find a lawyer, not ones that have been really seasoned, you have to find fresh lawyers that still have that love to do the right thing, rather than just to make money. So you have
yeah.
to.
Not to be sexist, but no man will act this way, and only women could or have a big heart to help people like me in situations like that. It happened in the past, and it will have hopefully it'll happen. But if I look for things like that, I will look for women, because it's impossible. A male lawyer will have a big heart to help me out for that. I really doubt it. So
Well, women tend to be more nurturing.
yeah, exactly. So so just an advice, by the way. It worked for me in the past, and sharing my success story with you guys.
Awesome. Cool.
Very cool.
Nathan.
So do you want other what other sci-fi technology do you want, Ben? I forgot.
How about to make you like really big or like really small?
Oh, I can't, man.
Yeah, like in the movie, I forgot the name of the movie. They shrink or they grow up.
That's Ant-Man.
The Ant-Man.
Man.
Yeah.
There wasn't. I forgot where I heard this, but they're talking, if we're really gonna if we're gonna time travel, it cannot be in our physical size. So shrinking was part of that. Like we have to shrink in order for us to travel faster. In time we can't.
Yeah.
It would be like much easier for us if we shrink our size to travel faster, rather than keep our size and travel the speed of the rate of speed that we need to achieve for time travel. So
But the only thing you need to do is convert convert all the charges in your body to you have to convert the electric charges into kinetic charges, just like the annihilation process I just talked about. So you convert the electric energy into kinetic energy. This way you'll travel the speed of light.
Just for you, Phil.
I love it.
Every time they take your idea.
Yeah, so true. Thanks, man. You
Send that to NASA.
That's funny.
yeah, get us in top secret mail and
Okay, how about, have you guys heard of Willow, the Google's quantum computer that has discovered a parallel universe? What do you guys
yeah,
what's your take on that?
they don't have a formal evidence of parallel universe. It's like at some point they were saying they prove that time travel in the past is possible using quantum energy or whatever. But it's not traveling. The quantum particle is not traveling in the past. It's just travel faster than the speed of light. They proved that you can go faster than C. So they kind of confuse everything. Their mind is all confused, and they end up with these clickbait titles and things like that. But if you dig deeper, they claim it's official, but if you read the text, it's still hypothetical most of the time, or they misinterpreted something. So I don't believe in parallel universes. I know they don't exist.
Well, question for you: Isn't there's something called resonant energy? Resonant energy is another form of energy rather than the main one. So if this exists, and this exists, this is a parallel to this. So what's the difference in having a parallel universe that runs on the resonant energy?
Well, a parallel universe, if
an
you
energy.
just say parallel universe, people are going to imply that it's a different world
No,
that
we have to
does
think
not
of
interact with our world.
No, we have to think of frequency and energy. Yeah, anything is frequency and energy. So if we run off of the main one, but the resonant energy, that's still frequency and energy. That still constitutes as a collection of, that could create a parallel, energy side to side. So if we live in this one, why can't the other one, exist for real? But I don't know. Just I'm thinking of it from terms of energy rather than parallel universe, because everything is energy.
Oh,
So,
yeah. Yeah, that's a good question. I need to read more about resident energy.
that's Nathan's field. He knows a lot about resonant energy.
Yeah.
Yes, I do.
Yeah. Yeah, I need to understand Nathan correctly before saying anything stupid. I'll need to read your book, Nathan. Why don't you release a book?
Well, I'm working on it. It's just, I sent something up there. I'll show you resonance energy. And if Michael put it up. That has absolutely no wires attached to it.
Nathan, I want one of these things. Those are so cool.
There's nothing attached to it. It's pure frequency that makes plasma break out. So I laugh every time somebody tells me they know how a Tesla coil works. I just put one next to one and made sure the frequency was right, and I get plasma breakout just by frequency. Not by the amps, not by the volts, just by the frequency. Look at that. Just not attached to nothing.
cool.
Yep, that's really cool.
Yeah.
Yeah, frequency, if you hit it dead on, there's a ton of energy there. You don't need all these different sources. You just need that. I mean, think about it. On that very coil right there on the outside, I just created the hot energy of a Tesla coil. And on the inside, I can put a rod down the center and create the cold energy of a Tesla coil. So you put that in a sphere and build it out, just like that with, different levels. You can create the sun if you wanted to. It's really not that hard. You just need to understand frequency better.
Oh, yeah. That's really cool. Yeah.
But you don't need a parallel universe. We already live in a frequency world. We don't realize it.
Yeah. So,
I mean, think about it. Tesla's earthquake machine, he put in a specific frequency close to the Shaman resonance, and he shook iron itself. I mean, think about it. That's a tremendous amount of energy in order to shake buildings with the iron in it. I mean, I think it was 9.83 that he put in there. We're looking at 7.83. Not that far off. He didn't hit it directly, but he hit it right close. I'm going to tell you right now, to produce that amount of energy, you're going to take a ton of nuclear reactors to pull that off. There's so much more energy in it than conventional means of producing stuff. We just don't understand it that well. So
yeah. But one day, I'm the type of the person that I don't understand for a long time, and then I just wake up one day and I don't understand everything. So I'll let you know when I understand what you're talking about, Nathan. Because I know in general what you're talking about, but not in detail. So that's why I would like you to have a repository. Material, I don't know, links to GitHub, or you can post documents.
I run everything by Nathan.
They start figuring things out, man. It all just works out.
Yeah.
Yeah.
Blow it up. That's how you learn.
Yeah. Try it and find out, huh? Every once in a while, man, that's just what you got to do. So I actually have another one here to show you if you're okay with it, Mike. Give me 1 second and I'll send it to you. I wanted to make this video right here because I'm doing something special, but it's completely against mainstream, and I know most people won't understand it, but hopefully you do. I got the rod down the center of my Tesla coil. It is simply going to my Rodin coil, and I have the mysterious can here. It's not hard. It's just a can with tape on it, electrical tape, a couple layers, and then I have a winding on the bottom, and then a winding up above it. And that's just 14 gauge copper and some shielding. So basically wall wire. And as you can see, one of them's connected to the can, the other one's connected to just the wire. They're both going to a bridge rectifier right here, and then into my capacitor. Now, I have a motor here set up, but I don't think it's going to run. It's been sitting outside for a very long time. So all I want to show you is how the energy builds. And it takes a little while because that bridge rectifier is not made for this. But let's go ahead and turn everything on. And yeah, I put some fans over here. I was doing another experiment with this, so I needed to cool it off some more. So I just threw up some fans over there. Anyway, okay, everything's fired up. Bring that up to 11 volts. Bring it up to about 17 volts so you can see it. There you go. Now, here's all I'm going to do. I'm just going to show you the numbers that come out of this. Sorry, let me camera set. And we are set on volt. That's 5.2, 5.5 so far. Bring it down to amps. 1.26. That's not bad so far. Let's give it a few more minutes. This may take some time, but we're going to let it go. Again, the full bridge rectifier should probably be some better, faster switching diodes. But that's okay. We do with what we have here until we get the right stuff. So the goal here isn't so much how fast it does it. I just want to get usable voltage and amps out of this thing. I don't know the best way to show this. By the time I get over here, it looks like it sucks. So we're still on amps. There you go. 2.24, 2.30. Now, a lot of people tell me you cannot get usable amps out of this. Well, in that capacitor, it'll stay in there. Let's check the voltage. Turn on a little light. There you go, that's respectable. 16 volts. Not bad. We'll give it a little bit more time to charge up. Again, we're 17.5 volts going into our Tesla coil. And circuit's running good. No issue there. So just give it a few more minutes to charge up. So let's look at our amps again. Turn on a little light. 3.4445. So the amps are growing. Go back to the volts. .21 volts. So right now we have usable energy. Now again, like I said before, it's taking its time to get there. By no means is it going fast. But considering what we're getting out of it, I'm not going to say that's a bad thing right now. We can fix the speed thing. That's not a problem. The problem we usually get is it going to be usable voltage? So increase the speed, we should be able to do okay. So we're about, what, 5.5 minutes in. So in about 6 minutes, we'll check it again. And like I said, the only thing I'm looking for here, guys, is I want to make sure we have usable volts and amps. Now, I don't expect any motor to run or anything right now, and I probably don't have it set up the right way for that. Again, we'll just take a look at the setup real quick. There's my cap. There's my can right there. Again, why is it working with this? I'm inverting fields, guys. I'm taking a one-wire energy with the dielectric on the inside and making it to the dielectric on the outside. It's that simple. I'm taking a wire wrapped around it right there to make amps out of it. And it's a simple soda can. But it's knowing what you're doing, not what the parts actually look like. There's the rodent coil, again, connected to the one-wire energy at the bottom of my Tesla coil with the rod going down the center. So Go back and look at it again. And we are still in volts. Sorry, I'm trying to get that wire out of the way. 28 volts. We are in amps now. 5.20. Now they're all in DC. There's no question about that. They're not AC, they're in DC. Again, the bridge rectifier right there puts them in DC. And, you know, we're just taking radiant energy and we're switching it back to DC voltage. So we're at 7 minutes. Like I said, this is, take some time. We'll check it again in a few more minutes. All I want to see is if it gets past, you know, maybe up to 6 amps. 17.5 volts. So we're definitely not in over unity territory, that's for sure. But we are getting some usable numbers here. Let's see, we're still in amps. 5.83 amps. We're almost to 6 amps. Go back to volts. 33 volts. Not bad at all. So we're swapping the energy coming out of the rod down the Tesla coil, this radiant energy. It's negative energy, however you want to call it, cold energy. I'm using a soda can to switch it. What is the big understanding of this soda can? Because you're going to probably want to know this. That wire right there on that top. So say if I just take these multimeter wires and I take one and I go like this and I loop it. Now I'm just going to counter wind it to the bottom winding, the opposite of that, and just take it like that and wrap it around and tape it. It's as simple as it gets. But it'll allow you to pull current out of something that's just voltage. And this goes back to an understanding. If you take a ferrite core and you put windings on one side of, you know, very high gauge wire, then you put very low gauge wire, which basically means you're going from very thin wire to very thick wire. It'll pull more amps out. People use it to make welders online. You can look it up. It's just as easy as that. We're simply using some smarts and understanding to get this. We understand conversion. That can is flipping the field so I get voltage and amps out of it, not just voltage. So we'll check it again. We are in voltage right now. $39 volts. You see it climbs. Turn the light back on. 7.12 amps. That's not bad at all. Now, before it gets any bigger, I'm going to discharge this capacitor. So, let's take a look at that. You say, well, is it in it? Let me turn everything off. Don't need anything going back to a circuit. Don't try this at home. Okay, get all of it out. And there you go. Usable voltage. Can we make it better? Absolutely. Do we have a good start? Yes, we do. You decide what you think it is. I don't think it's over unity yet. We're not getting the voltage in there and amperage in there faster. We are getting a usable amount. That's a good thing. So I didn't even try the motor, guys. I didn't even want to bother. Look, it's not about that. It's just simply about, can we get the amperage up? And the answer is absolutely yes. That is a very simple winding that goes on in a soda can. That's all it took to get there. You decide what it is. I hope everybody has a great day. Thank you.
That was really cool. 7 amps. Wow. That's
No,
awesome.
keep building.
It
That
is really
capacitor
cool.
will hold a lot more than that.
That's so cool.
Well, I guess I should explain it a little more. I have an aluminum soda can, so it acts like an open core. But because it's mostly closed in and it's aluminum, it traps heat. The heat itself inside creates the amps. So that right there, I'm changing your guys' understanding just a little bit because I need you to understand this. When you create a cavity, you can up the amperage a lot because heat equals amps.
Oh, maybe that's all I need is a small can like that to put inside the coil to up the amperage.
You don't need that, Ben. You just need how I told you that circuit works, and you'd be fine.
Yeah.
But
Well, that's gonna be our next set of tests is testing the heating and how well this thing does for inductive heating.
now, with what I'm saying with the can, just understand this. This right here goes to Edwin Gray's over Unity car. If you can understand this in the way that I presented it, then we can fix the speed that it accumulates in the capacitor. We can also take the rodent coil, because I'm saturating the core with the energy, and take every single wire off of it and put another bridge rectifier can rectifier setup there and a cap in order to collect the energy. And it will have no effect on my Tesla coil. You see, the energy right there is saturating that rodent coil. That's what you guys aren't understanding. That's the whole over Unity device. You have to saturate that rodent coil. Now you can pull individual wires out. Guys, I don't run it in channel A and channel B. I run it on one wire. Now I can multiply the fields because I multiplied the wires. I took scalar energy on each level and now added each single one, and I can multiply the living daylights out of this thing. So running 30 caps, not a problem. You know, as long as I got 30 wires, which I don't remember what's in that thing. I think it's like 15 or 16, maybe 22, I think. But that's the understanding here. We get a ton more energy than what we put in because we understood saturation in the rodent coil. We understood conversion in the aluminum can. We understood how to capture it and rectify it to the cap. Guys, Edwin Gray, it's a fact. He built over Unity.
Yep, and he was suppressed big time. They went after him with a pitchfork.
That's why I don't show the rest of it right away.
Nathan, what can you not make that can produce energy? You're using cans, you use dirt, you use rocks, you use
Burritos.
like like what is it that you cannot?
Oh, it's so great, isn't it?
Absolutely.
Great burrito relay.
That was my favorite one, the burrito relay. They just created energy in burritos.
What did you use? Potato too? What else? Yeah.
I use grapes. I use my pumpkin pie from Thanksgiving. If it has a water content in it, this energy interacts with it. So it really does not matter what it is. Just give me some water in there, not oil. Oil won't work with it. It'll slow it down because the viscosity is too high. Give me something with a water content, and I'll amplify the living daylights out of it. I mean, yeah, like you said, Lulu, who does this? This guy, he goes and puts dirt, mud, you know what I mean? Goes out in his backyard and lights up ponds. He's just crazy old man.
Inventor.
Yeah.
Yeah, we're all mad scientists.
I like when you supercharged a wiener.
Which one? Supercharged? Which one?
The wiener.
Oh, the wiener. Those things are so great. They have so
Multiple
much
meters.
salt and water in them.
Oh,
in
yeah.
those hot dogs.
Yeah.
Like they are so much energy you pull out of those things. And it's all condensed in that wrapper, the wrapper that they put around the wiener.
The
It
capacitor of
stays in
the
there.
future, man.
Yeah.
Oscar Mayer meter.
I tell you, we don't understand energy the right way. I'm just going to tell you that. Everybody who tries to tell me all about that, I'm going to tell them right now, you do not understand it. No, you could spend one day with me and come out so puzzled and confused by the end of the day, you will never see energy the same again.
Yep. A lot of it has to do with the heaviside component.
Yeah. Well, they all knew it. They didn't put it in all the physics books because they knew as soon as you figured this out, all of their industries go to crap. Every last one of them. Because if you have OD unity and electricity, why do you need all these different oil and all this other stuff? You just don't need it. And if you can create it out of rocks in your backyard, man, why do you need some of this stuff? So, I mean, look, I could literally take a piece of granite, get it wet, and I can conduct electricity right to the whole thing. So,
Quartz, because of the quartz.
well, yeah, because of the quartz in it, yeah. Well, not only that, the feldspar in it, it sucks up all the water. So it's like holding it in compression to the quartz. You're compressing the quartz and you have water that sucks up into the rest of the granite itself. Now it holds it in and compresses, and you're putting the energy into it. You have a massive multiplying field.
You should grow like a pumpkin patch. And yeah, and it'll be like a natural like cap bank.
You got a pumpkin for a house. All kind of radiant energy in there.
Radiant pumpkin energy.
Supercharge your cat.
Oh. Those cats hear frequency better than I do. They don't come around. Not when I'm doing my experiments. They don't like it. I can't hear a lot of stuff, guys. I'm sure you probably already know that's why I wear the headset. I cannot hear a lot. I'm like deaf most of the time. So I tried to use my hearing aids during experiments and they exploded on me.
Oh,
Because the frequency's so high. And then I put the mic in there and everybody on the live show goes, oh my God, there's so much frequency going on. I go, I still can't hear it. None at all.
yeah, it's pretty cool stuff. Yeah. You have to play with that stuff in order to really understand it.
Oh yeah.
Because
So I think it's hilarious, Mike, because I talked to Mike. We went back and forth a couple of times on how to get it better. And they go out there with a soda can and just nail it. And I know people are looking at it like, oh man, you didn't put the meter in line with it. You didn't show the current coming in. I don't care about that stuff. I care that the capacitor holds the value. That's all I was trying to
it's
find.
the conversion. It's the conversion from the supercharged dielectric field, or you could call it the heavy side component, and you're confining it in that space inside the can.
Mm-hmm.
So when it's confining it, all that energy is being stored in that can. It's not allowing it to radiate out like a Tesla coil does. It's holding it in. And because of that, it's supercharging the copper pipe and the wire, and you're channeling that energy through the wire, because all really, energy flows on the outside of the wire. Energy doesn't flow inside the wire. It basically is spinning around the wire all the way down, and then going through the rectifier, and then from the rectifier into the capacitor, which makes it into real power that's usable. So there's the energy conversion.
Well, the thing is, Mike, it doesn't hold it all the way. So it's leaking everywhere. That can.
Oh, it is. Yeah.
Oh,
imagine
yeah.
There would be some leakage. Yeah.
I need some mica.
Yeah. Mica would be good.
I need a real heavy holding into that field. This sucker, man, it's wild. This energy that comes out, it's not exactly negative energy you get out of a circuit.
You know, if you were to get, like juice cans, all right, put about 2 or 3 different sizes of juice cans inside each other. So you're creating almost like capacitor plates. On the
You do know that's how Edwin Gray did it, right?
Yeah, exactly.
It's the same thing in the Testikiba experiment.
Yeah,
they use the same exact capacitor.
Yeah, and that's what the Edwin Gray tube is. Got the disruptive discharge spark on the inside, and you got 3 rows, depending on how you design it. I've seen as much as 3 or 4 of these. They use copper grating. You can buy them at Canadian Tire. Actually, they're kind of expensive now. And you do 3 rows of them, bigger, and bigger. So you go, say, 1 inch, 2 inch, and then 3 inch. So you have 3 layers of tubes inside each other. And every time it hits a layer, it's multiplying the power and converting it over into real power. So in an actual way, it's kind of like a modified capacitor with a disruptive discharge on the inside.
So think of that same thing, Mike, but go every other one, right?
Yeah.
With DC high voltage ready to go into it, right?
Yeah.
So what I'm doing is I'm going to immediately put heat in the system and flip it from cold to hot just by putting that in there, right? So I want a high amp DC flyback field that, just like you get out of the back of the TV, you can plug that directly into this, right?
Yeah.
The amount of amps in there will heat that sucker up real quick and flip that field from cold to hot. So I'll go right into hot energy instead of being hot energy all the time to the can.
Yeah.
I'll be on cold all the time so I can keep the car cool. And then once you hit the pedal, it all converts to hot energy and dumps a boatload of DC power into those caps.
Yeah. Yeah, you just got to worry about that tube, that it doesn't overheat. So I'd have some...
well, that's why it's cold most of the time.
Yeah.
If it's always in cold energy and you only need it when you need to fill the cap bank.
Yeah, that's true too.
They're not using it all the time. You think about when you hit the gas in the car, you think you have your foot on the pedal the whole time you're driving.
No.
But you don't.
No.
It constantly comes off. It constantly goes to the brake. It constantly... I mean, you're not doing it in an idle mode at the light. You think about the time you're actually putting, unless you're on the freeway. You know what I mean? City driving, you don't have it on even a quarter of the time.
Yeah.
So
yeah, that'd be cool. Yeah. Yeah, the gray tube is what makes that thing tick.
all with a little soda can, a little bit of knowledge.
Yeah. Yeah, that'd be cool if you had like 2 or 3. See what the change would be.
Oh, yeah. Well, trust me, Mike. I play with this on those light bulbs and pull it out. And I'm going to tell you right now, this bridge rectifier setup, it is not even close to what those light bulbs pull out. Because it's more of a trickle. Now, it may change if I change the diodes in there, put the load on it. That all may change a little bit.
Yeah.
But at the speed it's at right now, not close yet.
Yeah.
So.
Yeah, if you it's a balancing act. I even did it when I was doing with the Renegade. I was trying to pull as much current from the rectifier into the cap to fill it up quickly. So the one I had was, I think it was 80 volt, 20,000 microfarad. So it's those big blue ones, right? The big blue capacitors, similar to what you had in your video. And I could get it up to 30 volts with less than 10 seconds. It's like, boom, it's there. Like when I did the plasma tube, 1 wire again, similar thing. And I put that into a 300 volt, 10 microfarad capacitor. It would charge it up to 140 volts DC in less than 5 seconds. It was just like, boom, it was there fast.
Yeah, well, choosing your capacitor too is something, because 300 volts we may not need, right?
but it's only at 10 microfarads, very small capacitance. That's why it's able to charge. But what's good about it, I found the right capacitor to allow that current to flow,
Mm-hmm.
and it charged it very, very quickly. And then after the capacitor, I could hook it up to a 4-watt DC LED bulb that you use in the wall, and it lit it up, brilliantly. Well, we've seen the video on it before.
Oh yeah.
So yeah, choosing the capacitor for what you're doing is critical, especially the size of the microfarad that you're using. Obviously, smaller microfarad, your current and your voltage is going to climb way faster. The higher your capacitance and voltage, it's going to take a little longer. It's going to climb, yes, and you'll hold the charge longer. So you can hook up a small little DC motor. You might burn the sucker out because it's going to get instantaneous power. You might get 2 amps through a little model DC motor. Might smoke it, but it'll work.
Well, I'll pass frying it, Mike. Yeah, I just think it's funny, man. You get the right capacitors, it's fine. You can use big ones and small ones. So big ones in the middle, and then like when I say the middle, I mean like everybody had the thing going like this, and there's 2 caps. Like those 2 could be big ones, but then the caps to run the vehicle, you need fast discharge and fast charging.
Yeah, I think he was using microwave oven capacitors. Yeah, just
I think it was Don Smith.
Yeah, like I got giant caps. I got they can hold 2,800 volts DC at 10 microfarad, and they're huge. They're this big, big giant suckers. I got 4 of those. And even with my Renegade device, I was able to fill those up pretty damn fast. With the Don Smith one, I turned it on. It got up to 900 volts in less than 10 seconds. Right? And when I discharged it, it threw a spark about 1.5 inches long.
Nice. So I use the capacitors that come off the ZVS board I buy, right? They give you 6 of them.
Yeah.
And those things charge instantaneously.
Yeah, they're what, 10 microfarad or less?
Yeah, they're really small. So they're immediately charged, immediately have energy.
They're what, 600 volts?
This is the...
Yeah.
Let's see if I can't see that. 0.33 UF.
Yeah.
15%. Looking for the voltage. It tells me hertz. It's so hard to see. I can't see it. I see a serial number.
Yeah, should have.
But they're cheap. I got a bunch of them. I might just make a giant capacitor bank.
Yeah, those are 3.3 microfarad. They're very tiny. So they charge up like instantaneously. I imagine those ones are probably anywhere from 3 to 600 volts DC. At 3.3 microfarad. And if you got like 6 of them in line, then that makes sense.
Question: the soda cans. You said if we put 3, so 1, 2, and I don't know if this is aluminum or not, but it's okay. What do I do after here? I put them 3. I space them out. They don't touch, right?
Right.
So,
Yeah.
okay.
They got to be isolated. And
Okay.
if you have a spark in the middle of it, then it's going to radiate out.
Okay, so I could from the bottom, I could put like maybe a rubber piece so it insulate like that way they don't touch, right? Or would that
They have to be separated. Yeah.
Yeah, but or should I put like a silicone, like the hot glue?
Silicone or
Stuff.
rubber.
Okay,
Anything that's
piece of wood, small piece of
even
wood.
wood. Yeah, but you don't want the wood to burn because
Okay.
you're going to be putting some high voltage through it.
All right. What's the next-
Probably rubber is probably going to be your best separator.
Yeah, those things that come on the bottom of the furniture. There's some of them are like rubber pieces, or
Yeah, you can make it fit.
So, hold on. If you take those cans and you just cut off the bottoms
Okay.
and leave it as a hollow, and then put the main tube around the entire thing, and you take plastic or rubber and suspend it in between each layer.
Okay.
Then you're set. You're good to go. You got a radiant field that goes through all of them.
Okay.
You need a heat trigger. So
Okay.
you need some kind of a hot voltage that goes in there that'll interact with the energy that goes in. So I know that DC high voltage to a flyback interacts with this Tesla coil energy without a problem, and it amplifies it. So I already know which field it is. So if you use that and you put it in there, it'll immediately trigger the whole thing to go hot. And then as soon as you let off that DC high voltage, it goes back to cold.
Okay.
That's the understanding. The radiant energy will go right through every one of those cans and fill every single layer without a problem.
Next, I would, if I have like a wire, like I can strip it, get the little clamps, clamp it on there, plug it, or use a power source.
Yeah,
What's
but
next?
you're going to want to use a DC power source. You have to use a
DC.
CPS like what Nathan's using.
Okay.
But
I'll
be careful. That's really, really high voltage he's working with.
Okay.
Yeah.
Well, I mean, I'm trying to get the concept. Maybe I might do it.
If you're not confident with it, please don't do it, because you can, this is getting into dangerous voltage range, right?
I'll wear gloves. I'll wear the isolating gloves.
Yeah, it starts out with minuscule volts, like 17 volts here and maybe 15 volts there. By the time I'm done, we're well over. How do I say this? It would be more like 110 volts coming out of it and like 20 amps by the time I'm done multiplying everything out, which isn't bad, because we would normally be at super high voltage, like 60,000 volts. But because I'm pulling amps back in, it drops.
Yeah.
So it gets more like, wall wire when you get to it. The same thing, but we're not pulling the AC field out of it. We're leaving it in DC.
Yeah.
Okay.
Because the whole idea behind Edwin Gray was, can I run a motor? So if I took a Tesla motor, can I run it? The answer was yes. Can I create a Bedini motor to put on that as well, so that it continuously runs, no matter if you're pushing on the gas to go forward or not, it continuously runs. So it's in constant motion, so it's in constant refill of the capacitor bank. That was the genius behind it. So the other motor only engaged when it was time to run forward. Other than that, it had free spin.
Okay.
Cool. Well, we're at the top of the hour, guys. I'm going to call it a night because I'm kind of beat.
I have just a quick thing to announce.
Yeah.
If you don't mind. It'll be quick. So we had some big news behind the scenes, folks. Okay. Backstage, we've been testing the micro vortex coil, and it wasn't working with the lightning thief, but it's showing promise now by hooking it up to the lumen lamp board, which is basically the same board with a different potentiometer. And this is made for more of a smaller coil. So I had a feeling this might be able to show us that, what range it works. And I hooked it up, and it works. It doesn't exactly light the room, but it flickers just enough to tell us that we can hook up the multimeter to the potentiometer and fine-tune the lightning thief setup and tackle the resistance question. And once that's dialed in, introducing what I like to call the micro thief, a compact coil system that just might surprise us. And we also have yet another discovery I just made backstage by hooking up 2 lightning thief devices to 1 pickup coil, utilizing 3 in total. They both work by picking up high voltage. So you can tune it so they kind of half light, but you have a green and a yellow, which breakdown voltage requirements is like 120 and 90, I believe. So that's like extraordinary news. If you want to see those behind the scenes discovery videos tonight, and check it out now, it'll be uploaded tonight on my Patreon and YouTube for paid members after this live stream. So making it available first for paid members before I release it to the public next week. You absolutely don't want to miss these important updates, folks. Subscribe now and get ahead on this technology and get it out there.
Awesome. Cool. Well, it's been an awesome stream tonight. Actually, Philip did an excellent job tonight.
Yeah, good job, Phil.
Phil.
Yeah, Phil's work was amazing.
Yeah, really good.
Yeah, so you can pre-order your sci-fi technology, Ben, if you want.
Yeah, well, I want some anti-grav boots. Is that possible? That's what I want.
Yeah. Cool,
Or like
cool.
a hoverboard. You know,
Yeah, When you do that, you got to have that mohawk like Mr. T. You'd be like,
I want a replicator. That's what I want.
Yeah, I still have some work to do for that, but I want that stuff too, man. So awesome. I will figure out an easy way to create matter. So yeah, next step, Phil. Come on.
Yeah, I've also posted a link for Philip's Patreon. So if you guys haven't subscribed to his Patreon, you can do so. The link is there in the live chat. Nathan, you're doing your live stream tomorrow at 10 o'clock Pacific, right?
Yep.
And that's 1 o'clock Eastern. So if you want to check out Old Man Bill's doing his live stream tomorrow at 10 Pacific, 1 o'clock Eastern.
Yeah, Joe and I are gonna have some fun tomorrow, man.
Yeah, I might jump in there if you send me a link. Like messing it up a little.
Oh,
Anyways, yeah, that was a great show. Guys, stay on after we go off. Everybody, we go live every Friday night at 9 o'clock Eastern, 6 o'clock Pacific. And we'll see everybody next week. Take care, everybody.
Thanks, everybody.
Thank you.
Mañana.
In the depths of hidden files, trapped inside the secret circuits, unraveling through the miles. Oh, truth was masked by coded curtains. You didn't know we're shattering the silence. Feel the power. Revelations on the rise. From the shadows, light emerges, breaking through the veils of dark. 0 points and gravity converge, yeah. Dying voices, revelation start. Ancient whispers call. They're begging us to open our eyes. We stand tall, defying all their lies. Even in now, we're shattering the silence. Feel the power. Revelations on the rise. Forbidden knowledge we dare to see, unveiling secrets, setting us free. In this epic, we play our part with fierce hearts. You didn't know we're shattering the silence. Feel the power. Revelations on the rise.